right now, everything's okay. No matter where you find yourself, no matter what kind of stuff is going on in your life, underneath it all, everything's actually all right. You're okay. You have more power than you might be giving yourself credit for. If you have something that's going on in your life right now that's challenging, painful, it's just a reminder to take a little bit better care of yourself. Because you're worth it. You can have this feeling anytime you choose. matter where you find yourself, no matter what kind of stuff is going on in your life, underneath it all, everything's actually all right. You're okay. You have more power than you might be giving yourself credit for. If you have something that's going on in your life right now that's challenging, painful, it's just a reminder to take a little bit better care of yourself. Because you're worth it. You can have this feeling anytime you choose.
Hello, everyone. My name is Søren. I'm the co-founder of Prisma. I'm very excited to welcome you to the Serverless Data Conference, where we will dive deep into the topic of databases for serverless applications. But why dedicate an entire conference to serverless data? Well, first, because serverless is a really exciting technology for developers. It allows you to start for free and promises to scale to massive production workloads with no infrastructure to manage. We have seen our community choosing serverless runtimes for their projects a lot. With services like Netlify and Vercel really leveling up the developer experience, it's really no surprise that developers are choosing to rely on serverless for their applications. But not all is well in this new world of serverless. While serverless compute feels like a mature technology by now, serverless databases still have a long way to go. Today, you will hear from some of the companies at the forefront developing serverless databases. And we will show you how the Prisma Data Proxy can help you to use more traditional databases in your serverless applications. At Prisma, our vision is to enable any team to have its own reliable and scalable data access layer, while also making it easy to move fast and iterate quickly. For us, it all started with the Node.js ORM. We redefined what the developer experience looks like when interacting with databases. And we did that by providing advanced type safety support, great auto completion, and integration in your development environment. And that's why more than 100,000 developers have adopted Prisma for their applications today. The Prisma ORM supports a wide range of databases: Postgres, MySQL, SQL Server, and MongoDB, which was introduced earlier this year. But it doesn't stop there. Data access comes with challenges that require more than an ORM, especially when working in a serverless environment. And that's why we started working on what we call an application data platform. The application data platform will expand your Prisma Project's capabilities and help any application developer to go faster, build bigger. To show you that, let me introduce you to Emily, who's going to show you what you can do on the Prisma Data Platform today.
Thanks, Søren. Hi, everyone. Let me show you how the Prisma Data Platform works. I've recently been working on a team building an e-commerce application for a large retailer. We created a first iteration of the project using Prisma. We would now like to deploy it on Vercel and collaborate on the data together. So we have a GitHub repository with our project available and a database set up on AWS and ready to go. Let's get started. After logging in with my GitHub handle to the Prisma Data Platform, I'm going to import my project. I'll click Import, select the repository, and give my project a name. All right, now it's time to configure the production environment. We already have our database, so we're going to paste the connection string here. Note that if we were starting a new project, we could provision a database with third-party providers like Heroku directly from this place, which is quite convenient. Okay, so we have the environment configured. Now it's time to deploy. We have instructions to define the environment variables here on Vercel. So after clicking deploy and following these instructions, the app should connect right to the database. We can then just let the build run. All right, now that the build is run and the app is deployed, let's check it out. So I can immediately see that the price on this bag is wrong. And there's also another product, a coffee mug, that's missing. And it should be visible here. We'll need to fix that. Let's go back to the Prisma Data Platform and figure out what's wrong. Using the data browser, I can see all my data over here. We can see that it's the same data from my application. The data browser makes it really easy to troubleshoot data-related problems in the application without leaving your browser. I can filter out the products to find the bag and fix the price. I'll click Filters up here, and I'll filter only for products that contain bag in their name. So here's my record, and I'll just manually fix the price. And click Save. Okay, so now that the price is fixed, let's have a look at that missing product. I'm going to remove the filter that I just added. And looking at all the records, I can actually see the missing mug is indeed there. That means there must be something wrong with the query. Let's check this out. I'm going to check the query used in the product listing page. It looks like the filter set by the query is only checking for products on sale, which it shouldn't be. I could update that and redeploy, but I'd rather make sure that this is indeed the reason before going through a whole new deployment, which will take time. That's where the query console comes in handy, since that allows you to run Prisma queries directly on the database. Let's take this query, paste it into the query console, fix it, and double check. So here it is. I've pasted it into the query console, and I'm going to make the adjustment to try it out. I was filtering out products on sale for some reason. Let's remove that parameter and verify the results. All right, looks good. Now the mug shows up. We can now make the changes and push them with more confidence. And after rebuilding, we can get our page looking just as expected. Finally, I can invite the rest of my team to the platform so that we can all use this together. Each team member can be assigned a certain role that determines what rights they have in the data browser. So as you can see, the Prisma Data Platform allows you and your team to easily work on various database environments, checking queries and data directly from the cloud. This can save a lot of time as people need to verify aspects of your application and troubleshoot problems on the go. Now that things work and we're getting closer to opening the application to more users, we need to ensure that the app won't break when facing significant traffic spikes. There's a common problem with serverless applications that leads to exhausting database connection limits. It's not always simple to fix. Let me hand you over to my colleague Daniel, who will explain that in more detail.
Thanks, Emily. Indeed, serverless is great at seamlessly dealing with traffic spikes. No need to plan for capacity, you just let functions be spawned based on the application's needs. But there's also a catch when working with traditional databases that weren't designed to work well with this approach. The good news is that any project on our platform also has access to a data proxy to help with managing database connections. We specifically designed this to help with serverless applications, and let me show you how it works by unpacking a typical traffic spike in different scenarios. In a non-serverless architecture, user requests are handled by a bunch of servers. Each server can deal with a lot of concurrent traffic on its own by managing a pool of database connections. So when the number of requests scales up, only a few servers are needed to respond to the spike in traffic, and database connections are heavily reused throughout the spikes. Now, in an architecture using serverless functions, the situation is different, since a lot of new functions get spawned as traffic spikes. Concretely, that's roughly one function per request, and each function will open a new connection to the database. The first problem is that opening a connection to the database is slow, and thus increases the latency of each request. The second problem is that there are a lot of ways and chances to hit the limit of the connections allowed by the database, since functions and their database connections are much less likely to be reused. This overall leads to slower requests and having a portion of them fail. This and users facing errors, which is obviously not great. So, in short, in a serverless application, the number of database connections stays close to the number of concurrent user requests, while traditional architectures that use servers reuse those database connections a lot more. And so, we've designed the Prisma Data Proxy to respond to this challenge and give you the best of both worlds. Looking under the hood of the Prisma client, we see that it is composed of a Prisma client API and a query engine managing the connection pool. We built the data proxy by bringing the connection pool into a hosted service that handles them appropriately and scales according to the traffic needs. Also, it comes with a nice side benefit of reducing the bundle size of the application, which leads to faster function loading times. Now let's take a look at this in practice by running a small load test on our project. To demonstrate how serverless functions can exhaust the database connection limit, we're going to use this demo Ask Me Anything app. And this app has 3 serverless endpoints, One endpoint is used in order to submit questions, another endpoint in order to increment the reactions, and finally the endpoint to fetch all of these questions. So now we're going to run a load test and see how it performs under load. So here we have the load test, and this load test simulates 150 virtual users that are in a loop making requests to those 3 endpoints that I mentioned. Okay, the report for this load test has been generated, and as we can see, we have 631 failed requests. What we're going to do next is I'm going to set up the Prisma data proxy and run another load test to see how it performs with the same load test. Now that I've configured the Prisma data proxy and redeployed my app, I'm going to run the load test again to see how it performs. So here again we have the same load test, 150 virtual users who in a loop are making the 3 API calls to those serverless functions. Let's take a look at the report. And here we have it, 4,737 requests, none of which have failed. This was just a quick taste of the Prisma data proxy. Okay. Now let me show you what happened when the data proxy was added to the mix. When a traffic spike came in, functions got created, but the proxy was handling connections separately. Connections got created as needed, not for each new function, which maximized their reuse. Now let's summarize. The data proxy enables you to enjoy all the benefits of what serverless has to offer, and work with the databases you know and love, like Postgres, MySQL, MongoDB, and so on. There's no need to plan your infrastructure's capacity. The application can scale seamlessly, while Prisma will optimize how to reuse database connections. Now, your app is ready for prime time.
Thank you, Daniel. The Prisma Data Platform connects to your code repository, your database host, and your preferred application runtime provider. As Emily just showed, this integrated approach enables you and your team to work on the database with confidence and speed. The data proxy acts as a bridge between your trusted relational database and the modern serverless application runtime. I'm really excited about this and look forward to see what developers will build using our platform. Everything you just saw is available today in early access. So make sure to sign up using your GitHub account and try it out now at prisma.io. Next, I want to show you how we are thinking about evolving the platform to support even more advanced use cases in the future. We are going to show you demos of early concepts that our teams are exploring. These demos are not actual products that you can use today. Instead, they are early concepts that we hope will give you a very clear picture of the direction we are going with the data platform. To start out, let me introduce you to Nico, who will start with a very popular topic in the serverless world, preview deployments.
Thanks, Søren, and hi everyone. If you have used Netlify or Vercel before, you have probably heard of preview deployments. They're so convenient. Preview deployments allow you to super quickly test a new pull request without messing with anyone else's version of the app. And that makes everyone a lot more productive. But the thing is, preview deployments fall short as soon as databases are involved. And we would like to fix that. What I'm going to show you now is a very early concept demonstrating what we have in mind to make sure that databases are smoothly integrated into all of your preview deployment workflows. We would love to hear what you think about it, so let us know your feedback. To illustrate our idea, let's come back to our team that's building the e-commerce application for a large retail brand. As I've heard, some changes are needed in the application. We have heard from the marketing department that a more detailed description of the product categories is needed. To achieve that, we need to update our database schema and change the type of the category field from a text field to a full-blown category model with a relationship to the product model. This is a breaking change, as the category field on the product model now represents a relation rather than a simple string. We're changing the category field from string to a relation with its own model in the Prisma schema. After adjusting the Prisma schema file, we use Prisma migrate to generate and execute the migration in order to apply the change. And finally, we push the change to a feature branch on GitHub and now get access to Versal's nice preview deployment that includes the change we just made. Let's check it out. Uh-oh, what's that? A 500 error that says database not found? Why is that? Well, what Versal is doing here is mapping my feature branch to its own isolated deployment. Usually this is great, but in this case, the problem is that my preview deployment doesn't come equipped with a database. And that's why the server crashed with the error 500 code before. So how can we solve this and make sure a database is available for my preview deployment? Well, we cannot use our production database, of course, so we rather need to manually set up a preview database and hook it up to our preview environment. But now the problem is that we don't have full isolation. All preview deployments will be using the same database. And as a consequence, there's a risk that database schema changes on one PR are incompatible with the ones made on another PR. For example, this is what the author of another feature branch would see if they opened their own preview deployment, since the new category model I added to my schema doesn't exist in theirs. In an ideal world, each preview deployment would automatically get its own preview database that matches the schema of the respective branch. This is exactly what we have in mind for Prisma. Meet preview databases. With preview databases, the experience would look more like this. First, a friendly Prisma bot joins your pull request and provisions a preview database for you. It then applies your schema changes by running a migration and even seeds data into that new database so that your preview deployment looks realistic immediately. With this approach, every branch can be fully isolated from one another. Having this workflow would be absolutely amazing already, but we think we could still do better. Did you notice that step where data gets seeded into the preview database? Seeding generally is great, but always getting the same data might not always be as helpful to ensure your app is really working as it should. So what if you could configure what the seeding step does? Let's dig a bit deeper into this idea. Testing applications with realistic data is hard because of several factors. You want to seed data that mimics the data that you have in production. But you can't show any personal information, secrets, or sensitive data to stay compliant with government regulations. And finally, seeding should be fast and use a reasonable data sample size. To illustrate this better, imagine that your application has this account page using data directly copied from production. Well, this isn't good, since we can see real data from a real user. This breaches a whole bunch of regulations in most countries nowadays. What Prisma can do is to lean on its schema file by enriching it to qualify data as being sensitive, like personal information, or secret, like passwords. We can customize the seeding step to decide on a logic to apply there, such as faking emails or generating random data for passwords, for example. This way, your preview can now safely be used without putting you or your company at risk. And to bring this further, the Prisma Data Platform could give you options to customize the preview database's size or region. This would allow you to get realistic data faster without triggering massive workloads. We are incredibly excited about the idea of preview databases, and we would love to hear what you think about it too. To summarize, preview databases would give you a fully isolated preview environment with its own database that already comes equipped with realistic data, while giving you various strategies to randomize data from your production environment to stay compliant with government regulations. This way, your entire feature development workflow becomes completely integrated. Very little overhead and a huge jump forward in terms of developer experience. At Prisma, we want to make developers more productive so that they can spend time building valuable features. And we think preview databases will greatly contribute to that. Speaking of, I hear that Alex is going to show how to deal with a situation involving multiple data sources. So let's see what that is about.
Wait a minute. Okay, got it. Yeah, thanks, Nico. That's right. I'm helping the team with an issue regarding the search functionality, which is not performing well at the moment. Sometimes it gets really slow, and we're hearing from more and more customers that they're unable to find what they're looking for. This is even causing us to lose revenue, so we must find a solution fast. Let's see what we can do and how Prisma would ideally help there. As developers, we know that search is a solved problem. We introduce a dedicated search database such as Elasticsearch or a search service like Algolia. Then we ensure to write the product name and description to the search database so that we can leverage the advanced search functionality to deliver a better user experience and solve the problem. Right? Well, no. Unfortunately, it's not that simple. As soon as we start making updates to more than one database, we run into the dual write problem. We all know that a network request or an application can fail, and it's important that to make sure that when this happens, we don't leave an inconsistent state behind. When working with databases, we can normally depend on transactions to take care of this. But transactions only work in the scope of a single database. So in this scenario, what could happen is that a new product is added to the application database, but before it's added to Elasticsearch, the application fails. This means that the new product isn't searchable, although it's available. The solution to this problem is to write to the primary database and have the data propagated to the search database in a consistent manner. A popular way to achieve this is using the change data capture pattern. The industry standard for implementing this is called Debezium, which is built on top of Apache Kafka. We are looking to extend the Prisma data platform to support this pattern in a way that is optimized for serverless applications while still being compatible with industry standards. Okay, that was a lot of theory. What I'm about to show you is a very early concept of how we expect this to work. So keep in mind, while the syntax is just an example, we want the overall flow to be very close to the final product. If this sounds useful to you, then we'd love to hear from you so that we can make sure to incorporate your ideas and requirements into our final design. Okay, let's jump in. Here's a simplified Prisma schema showing the models relevant for this example. The first step is to introduce a new data source along with the product search index model in the Prisma schema. We'll use Elasticsearch in this example, but you can imagine doing this with your favorite search service. Note that Prisma currently only supports a single data source, but connecting it to multiple data sources is something we're considering adding soon. With this, you could already implement the dual write pattern by manually updating the data in both databases. But as we discussed, we need something better to avoid data inconsistency. Now, we want to take data from the first data source and project it into this new Elasticsearch index. We'll do that by defining a projection that is responsible for propagating changes. With this syntax, we define that the values of certain fields in the product model should be automatically propagated to the product search index in the Elasticsearch database. Under the hood, the Prisma data platform takes care of all the plumbing so you can focus on your business logic of your application. With these changes, I can now create a new pull request that contains this data projection. Creating the PR will trigger creation of a new preview environment. However, our preview environment creation will fail since we haven't defined our connection details to our Elasticsearch database. So let's go ahead and do that. Any project on the Prisma data platform has the ability to define multiple environments so that this is easy to customize settings for these. We can now go ahead and define the new preview environment variable to fix the problem. Now we're all set. The PR is green. We can go check out the details how this works by clicking on Details. In the project view, I can look at the data projection I just added. And then I'll trigger the backfilling of existing data into the product search index. We can check out the backfilling happening here and verify that the data is being pushed into Elasticsearch with every change. And with that, our search issue from earlier is resolved. We can now rest assured that the search works and we don't lose revenue or hair over this. So let's recap what we've been envisioning here. With a couple of changes on the Prisma schema, we would be able to create data projections across data sources almost instantly. This allows you to forget about the infrastructure components needed to make this happen. Prisma would provision, operate, and monitor the infrastructure needed to make this happen, namely the components required for the change data capture pattern, as well as the persistent queue for offering a fully integrated alternative for Debezium and Kafka. This would guarantee that the application and search databases are always in a consistent state and enable straightforward backfilling when the data projection is deployed. You can imagine other usages for this, like building real-time subscriptions, projecting results of a complex query to a caching layer, or projecting data to a reporting system. Now, back to you, Zoran.
Thank you, Alex. This concludes a glimpse into the future of the Prisma data platform. The data browser, query console, and the data proxy is available today. I hope you're excited for where we're going next with the data platform. The data platform is still in preview. It's important for us to learn from you about things that aren't quite right yet. So as you start exploring the platform, please take the time to tell us what you think, what features you would like for us to work on next. For the rest of the conference, we have some very interesting talks lined up. I hope you will learn something new, and hopefully you'll have some interesting takeaways to share with your team. Please enjoy the show.
Thank you, Søren, Nico, Emily, and Alex. It's really exciting to see how the Prisma Data Platform complements the open source Prisma ORM and enables productive workflows both for individual developers and teams collaborating. And the best is that you can try it out today at cloud.prisma.io. So, now that you've seen the power of the Prisma Data Platform and our vision for the future of the data platform, we'll go deeper into two facets of serverless architectures. The first is serverless databases like PlanetScale, MongoDB, and CockroachDB. And second, serverless runtimes like Cloudflare Workers, Netlify, and Versal. But first, we'll take a 10-minute break. And in the meanwhile, I invite you to join the Prisma Serverless channel in our community Slack. If you're not already there, you can join the community Slack at slack.prisma.io. So following the break, we will have Greg McEwen from Cloudflare speak about Prisma and Cloudflare Workers. And with that, enjoy the break. Welcome back. I hope you enjoyed the break. I'm now honored to invite Greg McEwen, whose talk title is Letting Your Users Become Your Developers with Prisma and Workers. Greg is the product manager for Cloudflare Workers, and at Cloudflare he works with customers to define storage products that are radically easier to use than traditional cloud provider solutions. Prior to Cloudflare, Greg worked at Red Hat and MongoDB on their OpenShift and core database teams respectively. And with that, I now bring you Greg.
Hey everyone, my name is Greg McEwen, a product manager here at Cloudflare. I work on Cloudflare Workers, which is our serverless platform. Super excited to be here and talk to you all today a little bit, both one about the Workers platform, but also about the Prisma data proxy and how that integrates into Cloudflare's Workers platform and really lets you build some cool apps and some cool architectures that we're really starting to explore together. So I think the place to start this whole conversation is sort of what is a Cloudflare worker. It's sort of a different programming paradigm than a lot of people are used to, and one we sort of stumbled on as we were building out really tools that Cloudflare itself needed to scale. So a worker is a lightweight JavaScript isolate that runs in response to a trigger. Today, the triggers we support are HTTP requests or cron triggers, and the worker runs JavaScript code or WASM, and then can communicate with other downstream data and services, right, by making HTTP calls out over a fetch API. What's sort of great about workers is that they let you deploy at a global scale immediately and out of the box, right? So Cloudflare workers are deployed to every single one of Cloudflare's over 250 data centers. That happens in under 30 seconds. So you get code that rolls out globally, and then you can sort of work with immediately and have immediately deployed to your users. So what's actually under the hood here? How does this actually work? Well, we're running a lightweight V8 runtime for both JavaScript and WASM applications, essentially. We run what are called isolates, which we'll talk about in a second, but are a bit lower overhead than containers. So your code is triggered by an HTTP request or a cron trigger coming in and returns an HTTP response back. So you write code once and it runs in all of these different points of presence around the world. Makes deploys really simple and makes scalability really, really straightforward. So the first thing we kind of confront with this is why did you build workers? And the truth is we built it to give our customers the ability to write custom code, right? There are plenty of features that a CDN can implement that Cloudflare didn't. And we said, what if our customers could just write JavaScript that would actually let them build those features themselves? So we started there, and then we started building our own applications on top of this. There are a number of internal applications that run on top of workers today, and more have started coming over time. And what we realized is actually there's a lot of power in sort of this architecture being able to write these really lightweight functions that you can compose together and use to solve sort of bigger tasks. It really resembles sort of a microservices architecture. And we said, this is a really interesting programming paradigm, and our users saw that as well. They saw the ability to kind of have this trusted environment that that was in between, maybe their main server today, but also close to their end user, and the ability to modify requests as they were in flight was really, really compelling, and it made for a really great developer experience. The other piece is that this was an extremely scalable architecture because of the fact that we were using isolates instead of containers, so they could spin up almost immediately and could be composed together in really interesting ways. So they started to say, hey, we want to do more than just modify Cloudflare CDN here. We want to actually use these to implement our entire application. And that's where people really have been going with this. So the next question we get then is, okay, so you're running Lambda at edge then. You're running containers at the edge. And I mentioned this before, but we're not actually running containers. Right? We're running isolates, which are much lower overhead and can start up much more quickly. So V8 isolates, we can actually eliminate cold starts entirely, whereas a serverless container service like Lambda might have 100 milliseconds to get a container actually started. We actually can start an isolate in 0 milliseconds, and if you think that's crazy, you wouldn't be wrong to think that. The way we do this is when the TLS handshake comes in, we actually pre-warm the isolate and go grab it out of memory and put it so it's actually hot and ready to process requests right away, which is pretty cool. So you're able to kind of get this really high performance out of the platform without having infrastructure sitting around and waiting. And that's another really compelling piece of the platform. It scales up when you need it. It scales back down when you don't. And so our pricing can be really compelling and really cost effective because of the fact that you're only actually running when a user is actually executing code. So sort of a thought experiment here to kind of show you the different paradigm you have when you're building for workers versus building on top of a containerized system. Let's say you wanted to let your users run completely untrusted code on your platform. A good example for this would be, let's say I run a social networking site that has different communities that run on top of it. And I want to enable groups of moderators to go out and moderate the platform. And generally, one way this would come up is, they could interact with some API that I expose out to them, and you'd have a number of bot makers who would, develop bots for that platform and kind of figure out how to actually run these moderation tasks. And all of those bots would kind of interact with my API, which is my trusted sort of surface to expose that to developers. But I wouldn't actually run the bot code for them, right? It would generally run on their own servers somewhere else, and they would call my API over HTTP or something. And this is the way the world would work with containers, right? So let's say I actually wanted to take my users' code that they were using to moderate these, communities on my platform, and I wanted to run it for them. Let's say I wanted to be able to, validate what the code was doing, but also give it more flexibility to run. If I was going to do this in containers, this wouldn't really be possible, right? What I have to do is have to spin up this really heavyweight container for each piece of code that could potentially be running at once, and then I'd have to find some infrastructure to actually let them communicate across each other. I could do it over HTTP and establish HTTP server for each, but that's a lot of infrastructure for me to manage, and it's a lot of overhead, really. But you can sort of see where the low overhead piece comes in, because on workers, sure, that's sort of fine, right? What I could do is have my customer either deploy or run their own worker, which is already totally isolated by the design of the system. One thing we're seeing is that this is a really compelling architecture, actually, that we're working on building out further. I think it's an interesting thought experiment because it is something that sort of seems odd. It doesn't seem possible in a containerized world. But with these sort of workers functions, it makes sense, right? You're just calling another function that lives somewhere else. Sure, it's someone else's and it's not necessarily trusted, and you should have a different level of permissions that you give to that code, for sure. But it's easier to compose these things together and really build interesting applications and interesting pipelines. And that's something we're working towards building out now. We don't have a total story here today. It's a little bit difficult to do, but this is something that's kind of coming and is on our mind. And I think it shows how this sort of paradigm is fundamentally different, right? It's fundamentally unlocking new use cases that you couldn't build on traditional architecture. So I mentioned before that we're getting to this place of supporting not only these new architectures, but also just complete applications that exist today. And the most challenging thing for us to support complete applications at the edge today is state. Right, so we're really good at spinning up stateless workers all across the world in all 250 different data centers. The problem is, what happens when someone who's in Newark, New Jersey wants to talk to the same piece of data that someone in London wants to talk to, right? This is the same problem databases have encountered for years, but it's a bit different for us because generally your application servers are co-located in one small region, right? That's the first piece. They don't have to deal with this sort of global, massive number of connections coming into them. The second piece is that traditional databases use TCP. They expect their connections to be long-lived. The worker's runtime is built on top of V8, which you might know from the Chrome browser. There's no standard API for TCP, though we're working towards establishing one. And so what that means is that we don't support those traditional long-lived connections. That makes it difficult for us to support traditional databases. This also means when we look at NoSQL databases that support HTTP interfaces, those are great. I used to work at MongoDB, love NoSQL databases, but they all present differing interfaces, and that can be really difficult for developers to actually work with. And a lot of their data might be in a Postgres database somewhere, and they're not going to migrate that data just so that they can use workers to get the benefits of this global distributed serverless platform. That was a lot of buzzwords all back to back. So what is our general approach to solving this problem? What is our approach to data, databases, data platforms? One, we want to build opinionated tools that make new architectures possible, just like we're doing with workers for data. And so the big one there for us is durable objects. That could be a whole talk on its own. You can go read a little bit about them, but it's sort of our approach. It's loosely based on top of the actor model or the Orleans grains system that Azure has put out. Loosely based on top of those similar ideas, and the idea is to sort of have a extremely horizontally scalable system of objects that compose some higher function and can store data for you on the network. We also have Workers KV, which is an eventually consistent global database, and we've just announced R2, and we're really excited about R2. R2 is an object storage that doesn't have any egress fees associated with it, and so these are sort of tools that solve specific problems for developers. But there's a whole lot of tools out there, and there's a whole lot of data that exists in plenty of tools today, right? And we want to connect with the best of breed tools that fit well with our vision for that ecosystem, right? So that are really well designed for global data and are kind of pushing things forward and making data easier to work with. And Prisma is an obvious example of that, and that's why I'm here today to chat a little bit about the Prisma Prisma Data Proxy. Specifically. So what the Prisma Data Proxy does is it exposes an HTTP interface to your backing database. This is exciting because now workers can talk to the Prisma Data Proxy, which can talk to your backing database. It supports a large number of backing databases, MySQL, SQL Server, Postgres, and MongoDB, and gives you access to all of those from workers through a common API, though. So you have the ability to access your data regardless of which data platform it's actually sitting on, through a worker specifically, which is huge. This is now a way, for you to be able to build that full stateful application that you've wanted to build with workers and Prisma together. Prisma is also a great way to actually access the underlying data just in general, where you can sort of set your schema and not have to worry about writing the actual SQL statements to actually go back to the database and make those operations. This also opens up really cool applications together, right? So one is take your existing database and build out a scalable application on top of it, right? Just with the data you have. And each worker can have its own assigned Prisma schema within it. So you can have all these different schemas sort of layered on top of your, typical relational database you have. What's really exciting about this is generally with data proxies, they live in one specific region, right? Or your database might live in one specific region, and you don't get low latency across the globe. And that's where Cloudflare Cache can be really impactful, right? So in a worker, you get access to the Cloudflare Cache API, which is the ability to store arbitrary data inside of Cloudflare's cache, like the same cache we use for the CDN. And that's really exciting because now you can take this sort of single region database you might have along with the data proxy and scale it up across the globe, right? And be accessing data wherever your users are and storing it there. You could even layer in durable objects here as well if you need to go make writes back to your database to make those writes strongly consistent, even when they're acting on top of cache data, which is super exciting. I think that will help a bunch with sort of the single region nature of the data proxy and really help build scalable global apps from day one. So what sort of applications could you imagine building here? I mean, one that I think we would talk about is the ability to put authentication directly at the edge. So you can use Cloudflare's cache plus the data proxy to push auth tokens out and handle those right at the edge. We've talked a lot internally about doing, token revocation and those sorts of things. It's sort of the best of both worlds for workers. It's kind of a more advanced use case, but at the same time, really has low latency requirements, and being close to your end user is really great for that. Another thing, kind of more aspirational maybe, would be to build out your own GraphQL layer, right, with caching built in for your client applications and have, Prisma return results back to you. You process them and manipulate them and kind of expose a GraphQL GraphQL API that's globally distributed to all of your underlying applications. It doesn't stop here, right? You can build out full applications across the board, and the experience is really great. Got to test out the proxy the other day, and the ability to use Prisma inside of a worker really abstracts away a lot of the problems that you face managing and scaling infrastructure, both on the compute side with workers and on the database side with Prisma. I'm so super excited for this. Yeah, and thank you very much. If what I've said interests you, feel free to reach out to me and talk a little bit more about your specific use case. I'm happy to chat anytime. If you're interested in workers, we're always hiring. We're looking for people to help build out the platform, so I have to get that plug in. Feel free to reach out, and thanks again.
Thank you, Greg. That was very insightful. I can't wait to dig deeper into Cloudflare workers. We will now move on to our next talk, and I'm now delighted to invite Kevin Jerningan, whose talk title is Supporting Serverless Apps at Scale with the Prisma Data Proxy and MongoDB Atlas Serverless. Kevin is the Principal Product Manager at MongoDB. He started his career at Oracle in 1987 as a product manager, and prior to joining MongoDB, he was the Principal Product Manager responsible for Amazon Aurora Postgres. And now, without any further delay, give it up for Kevin.
Hello everyone and welcome. Thank you for taking the time to watch this presentation and demo. We're excited to show you some new capabilities which will make it easier for you to build and deploy serverless applications at scale with Prisma and MongoDB. My name is Kevin Jernigan and I'm a product manager at MongoDB on the MongoDB Atlas Serverless team. Prior to joining MongoDB in February of this year, I'd spent most of my career working on relational databases. I worked for Oracle twice, and most recently for Amazon Web Services, managing the launch and growth of Aurora Postgres. I joined MongoDB because I'm excited about how much easier it is to build applications with MongoDB as compared to relational databases, and I'm double excited about MongoDB Serverless and the whole serverless application paradigm. With me is Matt Muller, a software engineer at Prisma. He will give a demo of Prisma Data Proxy working with MongoDB Atlas Serverless. Okay, let's get started. We've already done introductions, so I'm going to dive into an overview of MongoDB Atlas and Atlas Serverless, and then talk about how to build and use serverless functions and applications with MongoDB Atlas. I'll then get into a couple of new capabilities that make it even easier to use serverless functions and applications with MongoDB Atlas, and Matt will give us a demo. Let's first talk about MongoDB Atlas, starting with a brief description of MongoDB itself. Most of you are probably familiar with MongoDB. As a database, MongoDB helps increase developer productivity with our document data model, rather than forcing you to think in terms of rows and columns and fixed schema tables, or wrestle with ORMs and DBAs and other points of friction in traditional application development. Atlas is our managed MongoDB service, delivered in all three major cloud providers. The primary goal of Atlas is to automate the boring, repetitive manual steps someone needs to take on when building and managing databases for applications. Atlas goes beyond automating to provide elasticity, hardening against common failures, and recommendations for improving performance and resource utilization. And Atlas itself is part of the MongoDB Cloud Platform, which includes things like integrated full-text search with Atlas Search, automatic user-controlled data archival with Online Archive, and mobile and edge-to-cloud data synchronization with Atlas Realm. MongoDB launched Atlas a little more than 5 years ago, and in that time, customer usage has grown 340% year over year, with more than 1.5 million database clusters deployed on MongoDB Atlas as of today. This has led Forrester to name MongoDB as a leader in the database as a service market, putting us in the same category as Amazon, Microsoft, Oracle, and Google. The key difference is that we're in the leader category because of one product, MongoDB Atlas, whereas the other leaders are there because of multiple databases. So with that background on MongoDB and MongoDB Atlas, let's talk about serverless. To set the stage, let's start with some common truths that I'm sure we can all agree with. Nobody likes sizing infrastructure. Sizing is a hard problem with ambiguous inputs at best, and Two pain points are often cited when we talk with customers about sizing: resource coupling and deployment friction. Deciding how much compute or memory or storage you need requires predicting future activity and translating your application's requirements into arbitrary units. Databases traditionally couple compute and storage resources together, which means that in order to get more of one, you have to get a bigger machine, even if you don't need more of the other resource. Therefore, you always have to get the machine that can meet the requirements of the resource you need the most of. This often leads to deployment friction. Teams don't like to have to go through a complex sizing exercise before every project just to select and configure the database. And the consequences of incorrect sizing infrastructure are plenty. If customers aren't confident in their sizing, they'll feel the need to constantly monitor their resource consumption and make sure you have sufficient capacity and otherwise adjust it. Or even if you size it correctly initially, your application may experience a change in workload patterns that requires you to go back and adjust your resources accordingly. If you have incorrectly sized and under-provisioned, your applications may become slow or even choke and be unresponsive if they hit a bottleneck. And if you over-provision, you'll have to pay for unused capacity, which quickly can become expensive. We can help solve some of these pains today. MongoDB Atlas offers auto-scaling on both compute and storage resources, which reduces the need for customers to manually scale up and down their dedicated clusters. We also offer professional advice on sizing clusters for various workloads, which can be delivered by SA or via consulting engagements. These solutions reduce some of the pain of sizing infrastructure, but not all of them. Let's revisit the 3 negative consequences again. Auto-scaling helps reduce management overhead, so that's generally good. However, when it comes to performance consequences, auto-scaling can't prevent all of them from happening. We invested a lot in building our auto-scaling capabilities to accommodate the majority of workloads, but they don't always respond fast enough to all scaling scenarios. And when it comes to cost, auto-scaling can save customers some money, but likely not a lot, since you're still tied to cluster tiers which have standard hourly rates. Even if your cluster is scaled down for some amount of time, you're still paying for all the resources that come with it, whether or not you're using all of them. So what does that mean? It means that today we can help relieve some of the pain of sizing infrastructure, but we may not be able to meet all of our customers' required capabilities. Specifically, there are 3 types of workloads that we can't really serve well today. If you have really imbalanced compute and storage workloads, the cluster tiering model may not be that attractive. While we do offer some elasticity when it comes to storage capacity on our dedicated clusters, it may not be enough for all workloads. For example, if you need the compute power of an M200, but the storage capacity of an M10, you still have to pay for an M200. Another scenario is really spiky workloads. Our auto-scaling mechanisms aren't built to handle large and sudden changes in workload requirements, so you may still experience performance consequences in your applications. And finally, not all workloads are constantly running. You may have a microservices architecture that runs a job once a day for 5 minutes, or once a month for 3 hours. These types of infrequent and sparse workloads aren't cost-effective to run on Atlas because there's so much idle time, and therefore you're paying for a lot of unused capacity. So why do developers care about serverless? Serverless delivers on 2 main goals. The first is elastic scaling, the ability to automatically scale up and down based on workload, including the ability to scale down to 0 resources when there's no workload. And then there's consumption-based pricing, which is a pricing model that only charges for resources used to service your workloads. The serverless application model results in an abstraction that frees developers from needing to think about servers, hence serverless. This model has the following benefits. You don't need to think about scaling up to meet increasing workloads. You don't need to worry about paying for resources you're not using. So serverless computing is a model that dynamically uses only what it needs and only charges for what it uses. Now, AWS Lambda is often credited with starting the serverless movement, and their cloud peers have launched similar capabilities, including Google Cloud Functions and Azure Functions. Let's dive into serverless instances on MongoDB Atlas. Serverless instances are now available to the public in preview in Atlas. We launched the preview back in July. This is a new serverless database offering in the market and has 3 main benefits. First is seamless deployment and scaling. You no longer have to determine what cluster tier or storage you need for your database, neither at deployment nor on an ongoing basis. With serverless instances, you simply create a cloud database and it will automatically and dynamically scale to meet the demands of your workload. Second is reliable back-end foundation. Serverless instances are built on top of the same foundations as dedicated clusters, and therefore offer many of the same built-in best practices you've come to expect, including continuous uptime, end-to-end security, backups, metrics, and more. It will always run the latest MongoDB version, starting with 5.0, and then following the rapid release schedule. And the third is intuitive operations-based pricing. In the serverless model, you only pay for what you use. In the case of MongoDB Atlas serverless instances, we will charge you for reads, writes, and storage. Now let's go through each of these in a bit more detail. Serverless instances come with the same best-in-class operations and features of a fully managed database, including end-to-end security, continuous uptime, backups, automated upgrades, metrics and alerts, and index suggestions. Ideally, developers rarely have to monitor their database or restore their data, but in case they do, we offer tools to help them troubleshoot and get back on track. Even though it's a preview, the serverless instances still include all these capabilities. All of this gets us closer to meeting those previously tricky required capabilities, but since it's just the first release, we still have some work to do. So let's talk about the areas we want to focus on over the next few years of MongoDB Atlas Serverless. The vision, of course, is to be able to use serverless to meet all of the required capabilities that you have for your workloads. And we are working on multiple projects to further separate compute and storage in serverless, as well as projects to improve scalability for spiky workloads both up and down. And we're watching very closely as customers bring a variety of workloads into the serverless preview to learn how to improve our pricing model. So what is our vision for Atlas Serverless? Well, we believe that the serverless model will become the default way for you to use databases in the cloud. This is because serverless realizes the promise of the cloud by abstracting and automating more and more of the low-level infrastructure configurations that developers and engineering teams don't want to have to learn or maintain. Now, it may take a while for the shift to happen in the industry. Many companies are still early in the journey to the cloud, and the idea of a serverless microservices architecture may be years away for them. Some companies may also never come around to adopting the cloud for one reason or another. However, the shift is already happening. The global serverless architecture market size is projected to grow from around $7.6 billion US dollars in 2020 to around $21 billion by 2025. Now that we've talked about MongoDB, MongoDB Atlas, and MongoDB Atlas Serverless, let's talk about how you can build serverless functions and applications using MongoDB Atlas. Before today, if you wanted to build a serverless app using AWS Lambda or Google Cloud Functions or Azure Functions and connect that app to an Atlas managed database, you had to write code to use one of the many drivers supported by MongoDB to connect directly to the database over TCP/IP. While this is relatively easy to do, it requires you to implement and maintain extra code in your serverless apps and can add significant latency to your database queries because a new connection will be created and then destroyed for each call you make to the database. Instead of making a traditional database connection, you would ideally be able to use a RESTful HTTP call to access the database. This would be much less coding work and much lower latency, but this wasn't possible with Atlas MongoDB. Until today, we're launching the MongoDB Data API, which provides HTTP access to do standard CRUD, create, read, update, delete, CRUD operations on a MongoDB Atlas managed database. This will greatly simplify the process of building serverless applications that need to access data in MongoDB databases. The MongoDB Data API is in preview, and we plan to support both MongoDB Atlas dedicated and serverless databases. Now let's get to the best part of this whole presentation, Prisma Data Proxy together with MongoDB Atlas. What if you're not only building a serverless application, but you're building one that needs higher scale, needs to be deployed on the edges of the cloud, using something like Cloudflare Workers. You'd like to connect the Cloudflare Workers to your MongoDB Atlas database in the cloud, but Cloudflare Workers can't use TCP. They only use HTTP. Now, you might think to use the MongoDB Data API we just announced, but sometimes the scale of traffic may be higher than can be easily supported. Because while the Data API doesn't require you to create and tear down a database connection for each database call, there's still some amount of connection overhead for each HTTP call. With the Prisma data proxy, you can now point a large number of Cloudflare workers at the proxy and use the proxy to manage a smaller and stable number of connections to a MongoDB Atlas database. This greatly reduces the connection overhead on the database, simplifies the application development process, and reduces latency for database requests. The Prisma data proxy is now available in preview for both MongoDB Atlas dedicated and Atlas serverless databases. To see all of this in action, Matt Muller is going to show us a demo. Take it away, Matt.
Thanks, Kevin. Now I want to show you how to create a Prisma project connected to MongoDB Atlas deployed to Cloudflare Workers. Let's jump into VS Code.
All right. So today we're going to be creating a simple logger that takes requests from the Cloudflare worker and logs them to a MongoDB database. Now I'm going to be starting from scratch because I want to show you how easy it is to actually get something up and running. It may move a little bit fast, but I'll be posting a link to the guide that you can kind of follow along on your own time. Okay, so to get started, we are going to need a MongoDB Atlas database. They are free to set up. You'll need Git and a Cloudflare worker account, which is also free. Okay, so I'm going to initialize npm, and then I'm going to install some dependencies. And we're going to be installing Prisma, TypeScript, some types for Cloudflare workers, Webpack, and TS Loader for compiling TypeScript to JavaScript. The next thing we're going to do is actually initialize Wrangler. And Wrangler is the official CLI for Cloudflare workers. It manages the deploying, developing on it, and everything else. Next, I'll use npm Wrangler login to actually log in with a Cloudflare account. I've already done this, so you would normally say yes, but I'm going to say no in this case. The next thing we're going to do is set up our TS config, so npx tsc init to initialize our TypeScript configuration. It creates this boilerplate TypeScript file. I'm going to go ahead and replace this with a smaller one. There's not anything crazy here. We're targeting ESNext, and we've got this Cloudflare worker types global type definition here that I'll explain a little bit more in a bit. Okay, so one of the cool things about Wrangler is it actually integrates with Webpack, and so we can actually supply our own Webpack config, and it will run this before deploying to Cloudflare workers. So we've got this Webpack config. It's pretty basic boilerplate. You've got this entry TS file, which will define that'll be where our worker is. It will output to worker.js. We're targeting web worker because Cloudflare worker environments are based on V8, and if it doesn't have the Node.js runtime or like the DOM or anything, so this is kind of the closest target for that. We've got some aliasing here to make sure that Prisma resolves to a Cloudflare worker type build. We're going to make sure that DevTool is none because Wrangler doesn't like evals, which this produces when it's on. And then the last thing we're going to do is compile a TypeScript file to JavaScript before deploying to the Cloudflare worker. Okay, and now we need to tell Wrangler where it can find that Webpack config. And so I'll just add this line here, Webpack config, and point to that file we just created. And now we're actually ready to initialize Prisma. So I'll do npx Prisma init, and that will create a Prisma directory and a .env file. I'm going to go ahead and copy and paste in our schema.prisma. And this is a very simple schema. It's got a log for which you can log levels, log a message, and log any meta information. And there's two preview features here that we've enabled. We've enabled the MongoDB preview feature for talking to MongoDB databases, and the data proxy feature for deploying a data proxy ready Prisma client. Okay, with all of that, we are actually ready to create a GitHub repo, and this will serve as a place to store our code for the Prisma data platform to be able to read. So I'll just go ahead and say Prisma MongoDB Cloudflare here, make it private, and I'll go ahead and create that repository. Okay, and then I will run the necessary commands to push up to that repo. Need to adjust the username here. Add all the files, make the initial commit, and push up to origin main. So if all is well here, we've got the new files here. Okay, and now we're ready to actually log into the Prisma data platform and connect our GitHub repo and our code to a new project there. So I'm going to go ahead and go over to create project. I'm going to name this one Prisma MongoDB Cloudflare. And I'll go ahead and import that repository we just created. Prisma MongoDB Cloudflare, here it is. And I'll use the main branch. Always takes a little bit for a second, but what you can see, it's figured it out up here. Okay, and then I'm going to use my own database and provide the MongoDB connection string that you can find actually right in here. And we're also going to create a data proxy, which will allow us to not run into connection limiting issues. Okay, we've created the project. Now I'm going to take this connection string and actually bring it into my project now. So this is actually a URL to the data proxy, which then connects to your MongoDB database, and it manages the connections and talking over HTTP. So now that we've got that, we are going to go ahead and generate a Prisma client that can talk to the data proxy. And so the way you do that is you define an environment variable here that says the engine type is talking to the data proxy instead of talking to the query engine binary that is the default. So we'll do data proxy npx prisma generate. We'll run this, and this will generate a Prisma client based on our schema.prisma file that we defined here. So now we are actually ready to define our worker. So I'm going to go ahead and create a source index.ts file, and I'm going to go ahead and copy and paste our Cloudflare worker. And what this does is upon fetch, it will run this function here. And this function just creates a info log with the request method and request URL logging any headers. And then it responds with what the request method was. It's a very simple function. So we've got a couple squiggly lines here. There's some interdependency with the tsconfig.json, which uses this and what the types are in here. And so you just need to save the tsconfig to refresh everything. All right, let's see if this is now working locally for us. So I'm going to go ahead and run npx wrangler dev, which sets up a Cloudflare worker-like environment locally. Okay, let's see if this is actually working as expected. So I go to localhost here, and we can see request method get, which is awesome. I'll run this a few times, and it looks like it's working. So now that we've got that, we're actually ready to publish our Cloudflare worker to Cloudflare workers. So I'll run npx wrangler publish to do so. And we're going to be given this URL here that I can go ahead and open. And you'll see actually that it works. Everything works as expected. So I'm creating a couple of requests here to see everything work. And now let's just verify that this is actually connecting through the data proxy and talking to our MongoDB database by going to the Prisma data platform and opening up the data browser here, which allows you to read from the database that you configured. And you'll see that we've got this log collection here. And you'll actually see that we've got all these messages that we've created. And so one of the interesting things about logging requests is you get to see how the browser works, which is kind of cool. So you'll see that the favicon is actually requested first, and then the actual URL we requested. So that's pretty sweet. What we've done was we set up from scratch a way to log your requests to a MongoDB database through the data proxy. And that's all I've got for you today. I hope that was informative. And if you have any questions, please reach out to us. Now, back to you, Kevin.
Thanks for the demo, Matt. That was really cool. So we launched MongoDB Atlas serverless instances in preview in July, and we're working hard to get to GA in the next year. Working with customers in the preview, we're continuing to improve on key areas for serverless: migration to and from serverless, seamless scaling for all types of workloads, and intuitive and affordable pricing. We believe that the combination of MongoDB Atlas serverless and Prisma Data Proxy will greatly simplify the process of building and deploying serverless applications in the cloud, especially for workloads that need to scale to high connection counts. The Atlas Data API will be ideal for developers who don't use Prisma and for applications that need a moderate number of connections. We're looking forward to working with Prisma to continue to improve support for developers building applications in the cloud. And please reach out to me or Matt with any questions. And thank you for taking the time to watch our presentation and demo today.
Thank you, Kevin, for sharing your insights in this talk. We will now take a 10-minute break and a quick reminder that we're hanging out in the Prisma Serverless Slack channel. So be sure to join in case you have any questions or you just want to share your experiences with serverless architectures. You can do that by joining at slack.prisma.io. Welcome back. I'm now honored to invite Sugu Sugamarane and Taylor Bennett from the PlanetScale team to the stage for an interview titled Scaling Databases for a Serverless World, a conversation with Sugu Sugamarane. Sugu is the co-founder and CTO of PlanetScale and co-creator of Vitesse, which he has been working on since 2010. Prior to Vitesse, Sugu worked on scalability at YouTube and was also part of PayPal in the early days. His recent interest is in distributed systems and consensus algorithms. Taylor is the staff developer advocate at PlanetScale. Before PlanetScale, she led developer relations at various developer-focused startups such as Keen.io, Stoplight, Transposit, and was also a full-stack engineer. Taylor is passionate about building great developer experiences, emphasizing empathy within product, documentation, and other community-focused projects. And with that, I now bring you Sugu and Taylor.
Hi, thanks everyone for joining us today. I'm really excited here today to have Sugu, PlanetScale CTO, for a chat. I just want to thank him for taking out the time to join us today.
Thank you. I'm excited too.
Yeah. We have some really interesting questions. We're really excited to be here today at Prisma Serverless Conference, where, more and more Prisma users are building in serverless environments. And in a serverless world, traditional database need to scale differently. They need to be on, rock solid infrastructure so it can handle this scale in a serverless world. And a lot of people don't know that PlanetScale is built on top of an open source technology called Vitesse. And it has scaled incredibly. And so I want to learn more about Vitesse. I want to learn why it scaled so well. And so first question, why did you build Vitesse?
Well, the year was, this was 2010. And if I remember correctly, we were at YouTube and YouTube was already pretty big. We were like the number 3 site by Alexa ranking. It was Google, Facebook, and YouTube. But that wasn't only it. We were also growing really fast because we were actually catching up to their level of traffic. So it was massive traffic and massive growth. And with that situation, the problem was really, really acute with the database because there was just not enough amount of tooling that we could throw at the database to keep it scaling. And that's when we decided, this something has to be done that allows us to leap ahead of this back against our wall situation. And when we actually took time off and built a spreadsheet of all the problems we have to solve today and all the problems that are going to come in the future, and looking at that spreadsheet, we knew that if we really have to take care of all this, we had to build a separate piece of software that actually put all these ideas together as one product. That's kind of how Vitesse was born.
Yeah, and were there any decisions why you picked, for example, MySQL and sharding to scale with Vitesse?
Yeah, MySQL was pretty much a no-brainer at that time. We are talking 2010. At that time, pretty much any sizable website, anything that served huge traffic was running MySQL. Facebook, there was Google Ads, and MySQL has remained one of the most easily scalable databases, like Uber, and you'll see that like even today, most of the big websites still continue to use MySQL. And us at YouTube, we were also already using MySQL. And so it was more or less a no-brainer. I think in today's world, there's Postgres, which is kind of coming on board. But in reality, if you ask me honestly, one should not overuse the features that these databases give you. Because they actually lock you into that situation. And also, it's better to solve some of these problems at the application level and minimize how much load you put on a database, because if you did that, you can actually scale things better.
Yeah, definitely. And so some people, we've said this word sharding before. Some people may have heard of this word sharding of when scaling a database. What is sharding, number one? And then why did you choose to use it to scale MySQL?
So the way I would put it is our infra team has been through multiple scalability scenarios. The way I would summarize it is sharding is probably the only way to scale indefinitely. If you have massive scale and you have to keep on scaling, sharding is probably the best approach to use. Simply put, sharding means that you are distributing your data. You are basically splitting up your data and distributing it across machines. So which means that if your data grows, all you have to do is add more machines and distribute it further. And therefore, you pretty much allows you to keep on scaling forever. That's the way I would describe sharding at a very high level. There's a lot of nuances about having to keep group data that is related together, etc. But those are the details involved when you make sharding decisions.
Yeah, and also, I know Mongo also has chosen to go down the sharding path too.
Yeah. I mean, Mongo is one of the leading examples of sharding. So, and it has definitely shown that you can scale forever if you use sharding.
Are there other scaling patterns that y'all tested out or explored that maybe don't work as well?
Yeah, I mean, like people have done all kinds of other ways to scale things. Like the one common solution that you hear about is caching, right? If you your database is not scaling, add a caching layer, and boom, you suddenly reach 5x, 10x scalability. But those are dangerous solutions, especially caching, because the problem with caching, one problem with caching is that if you saturate that, you're pretty much dead in the water. After that, there is no way to scale further. But there are bigger problems that you'd face if you in YouTube, we actually had caching. We I think we had a hit rate of 95% or something. And anytime we lost the cache, it was a panic moment, because at a 95% cache, if you lost that, your database load goes up by 20x, and there's no way a database can handle that, because we scaled by taking load away from the database, and the database load has grown. So you cannot send this traffic back to the database, and recovering from such situations becomes very hard. So overall, systems built like that don't handle outages and incidents very well. So that's one of the problems. There's also vertical scaling. You can keep on building bigger and bigger hardware. But now the fact that CPUs don't get any faster, the bigger hardware just gives you more CPUs, and eventually built-in bottlenecks in the software don't allow you to exploit all of the CPUs. So there are all kinds of problems and limitations that arise if you adopted other ways to scale. Another big caveat, though, with sharding is that you have to be careful about making sure that you keep things loosely coupled. That you don't couple. You cannot scale a system where there is too much interdependency between data, and such systems won't magically scale. So you need to separate things out, keep them separate, And that way, you can keep on repeating this process of scaling.
Yeah, that makes a lot of sense. So we've said the word scaling a lot. When we talk about scale, what kind of scale was Vitesse being run at YouTube?
Yeah, we actually, if you look at the number that we launched at in 2010, 2011 at YouTube, it may look small. It was actually pretty big then. We started out with we had 16 shards, and
when you say 16 shards, explain for the audience, what does that really mean? That would be helpful too.
So when we distributed the data, we split it 16 ways. So we split it on 16 different boxes. And so basically 1/16 of our user were on one database, the other 1/16 on another. So we had 16 such databases.
Okay. Yeah.
And so which means that when a user came in and looked at their query, the queries just went to one shard. So that's kind of how we started. We probably were doing 200,000-300,000 QPS. That actually grew by over order of magnitude over the last 10 years or so. By the time I left, we were doing millions of QPS. We were running on tens of thousands of nodes. When we launched, we were just 2 data centers. By the time I left, it was around 20 data centers all around the world. Each primary had 75 replicas. So it was pretty enormous.
Massive. It's very massive.
It was massive.
Yes. Yeah.
But the beauty was not the massiveness. The bigger beauty was the fact that the team that ran it was really, really small. We were just 10, 15 people running such a massive setup. And one person would go on call and they would have nothing to do. The only thing their job was, if you have no pages, your job is to plan ahead, make sure that, do you need to grow the disk space for this one? Do we need to plan another resharding? So so it was more of planning work that we were doing. We were not responding to that many outages.
Yeah. So Vitesse is now this default database for scale. This has been proven by, it's deployed at Slack, Roblox, Square, Etsy, GitHub, JD.com. The list is endless. How do you feel knowing that this tech that you've created powers so much of the internet today?
It's somewhat humbling and very exhilarating. It's exciting to see such big companies, rely on this software. But what I am more excited about is this software now through PlanetScale is available for the common engineer. This huge power is now available for the common engineer. Just with the click of a button, you can now have a Vitesse cluster up and running for you.
Yeah. I mean, I know when I was considering joining PlanetScale, it was very attractive to me from a developer experience standpoint that I could create a database within seconds. And also though that it made it easier. I didn't have to make all these complicated decisions of how to deploy the database and how I was going to get the correct version of MySQL up and how I was going to operate and maintain it over time. That was really interesting to me coming from my development background, but also it made me feel like I could build more faster. But with this move to serverless, and we're here at Prisma Serverless Conf, why is it important to you that PlanetScale is serverless?
Serverless actually is one of the most relevant pieces of advancement in technology, the way I see it. The reason is because today the software industry is extremely complicated with a really, really large number of deep stacks. And it is actually not fair to expect an engineer to learn all of these stacks. I actually remember seeing a big argument in a forum where someone was saying, oh, if you don't know how to bring up a database, then you're not worthy of being an engineer. And that's actually a totally unfair expectation of an engineer today, because today's engineers have to learn a large number of things just to be able to write what they need to write. There's a huge Ruby stack, there is a huge Tailwind stack, there's a huge React stack. Having to learn how to best use all those stacks And then you cannot go and tell the engineer, now you have to learn how to bring up a database. So I think in this type of environment, another company taking over that complexity and solving it for you, where you just click a button and you have a database up and running for you. And that allows you to, like what you said just before, focus on the problem that you have to solve as a developer.
Yeah, totally. And along the line, so PlanScale, like we wanted to make it serverless to make this development work faster and have developers need to not know one more thing. Why was it important though to pick Vitess for serverless to you?
Yeah, I mean the simplest reason is the fact that Vitess, a huge amount of investment has gone into making Vitess what it is today. I mean, if you want me to throw a number, it's probably in the hundreds of millions of dollars. Like a company had to invest that kind of money. Like YouTube had to invest that kind of money into this project to be able to mature it to this extent. And this maturity gives you all these powers of scalability, not just scalability, and also functionality. And that is now available to you. Like today, like the feature set that we have in PlanetScale today doesn't even tap into barely taps into probably like 10% of what Vitess can do. There's so many hidden gems and features that are inside Vitess that we'll get to expose sooner or later. There's the messaging architecture. There's the V replication. If I were to throw a simple example, Shlomi is one of the developers in the MySQL world. He's also part of PlanetScale. Just recently developed a feature where you can reverse schemas. You deploy a schema, there was a problem, you can immediately undo it, right? So those kinds of features you can easily build with something like Vitess.
Yeah. And kind of going off of that, Git-centric workflows, that makes me think of reversing a schema is kind of like reverting, have basically changed how we build the web. We have this idea that we can just fork something or branch something and have this different environment. And I'm really excited here at Prisma Serverless Conference because, Prisma also has embraced this idea of writing database schema in this like declarative way that also makes it easier to be portable, and we can share these schemas. We can make changes to these schemas and then merge them back.
That's the way to go. That's the new way.
But historically, though, the database layer has been, single branched, and maybe we're talking to some long running server or, a production environment, even not even a staging environment. At PlanScale, we have this focus on branching and schema changes. Why was that an important first set of features to you?
Yeah, I have to talk about Sam Lambert, our CEO. When he came on board, he actually experienced this problem when he was a DBA at GitHub. He found that the schema deployment is a nightmare. It's a nightmare for everyone. It's painful. And by far, he basically said that if we solve the schema deployment problem, we will make databases approachable by any developer, right? That was the problem he thought we needed to solve. And he knew exactly how it has to be solved, because you need to be able to make this work along with the workflow that is common to what a developer does when they are developing their software, which means that developers create branches of their source code. You should also be able to branch your database schema. And then eventually you have to deploy your source code in a staging environment, which means that along with the schema deployment, we need a staging database, right? With your branched out schema. And all of this should work together naturally and beautifully. And you should be able to bring this up and down as many times as you like in an isolated fashion for yourself so that another developer's work doesn't affect yours. So all this flow has to work beautifully for this to be nice and easy. And that, I believe, is what PlanetScale has brought up for the developers.
Totally. Yeah. And I think the idea of schema changes, we're all scared to make them. I think some people had started moving to NoSQL because they kind of felt like that helped solve some of the problems because it's not requiring those schemas. Like what's your take on, the good and bad with using that kind of way.
NoSQL actually, it is true. You don't need a schema for NoSQL, but you also, but at what cost, right? You do lose a huge amount of functionality if you go to NoSQL. There is a lot of power you can get from having a real database with a real schema. And the way I would put it is, schemas are not the problem. The problem is the workflow that is involved in deploying the schema has not been worked out well, and we believe that we have nailed it at Planet Scale. So I feel like if that problem is solved, then actually using a database is a lot more beneficial than using any key value store. Like even adding a simple where clause to an SQL like leaps you ahead of the number of things you can do with your software.
Yeah, totally. That's really interesting. So last question, I just wanted to ask, what is your advice for folks when they're scaling their tech stack today?
I would say keep things simple. Keep things as simple as possible, because the simpler it is, the easier it is to keep scaling it, because then it is easier to replicate what you have done and keep scaling it. Use SQL, but don't go overboard. SQL offers a lot of powerful constructs. Do not use anything that is too complex. Stick to simple where clauses, stick to simple joins, simple aggregations, and don't go anything else that SQL offers, because that will give you the best scalability that you can want.
Yeah, that sounds like great advice. Yeah. I just want to thank you so much for taking the time to chat today. It's been really awesome. I learned a lot. Hopefully others did. And also want to thank Prisma for having us to be able to have this conversation today. And feel free. We'll be around the conference if you have any questions. And love to hear your thoughts on what we talked about today. Bye.
Thank you.
Thank you, Taylor and Sugu, for the informative interview. I really liked how you emphasized Git-centric workflows for your database. In fact, I recently spoke to two former GitHub employees who are using PlanetScale and Prisma for their new ventures, and they were absolutely thrilled about the speed of development using Prisma and PlanetScale. And based on my own experiences of using PlanetScale since its launch, it's really nice to see how you're democratizing these powerful technologies like Vitess with a state-of-the-art developer experience and all of the benefits of serverless like zero ops and consumption-based pricing. Moving on, I'm now thrilled to invite Hassan El-Magari from Vercel. Hassan's talk title is Building Serverless Apps with Next.js and Prisma. Hassan is a developer advocate at Vercel. He's also a full-stack software engineer based in Philadelphia. He's passionate about startups in the developer tool space and building interesting side projects. And now, without any further delay, I bring you Hassan.
Hello everybody, and thank you so much for coming to my talk on how to build serverless applications using Next.js and Prisma. My name is Hassan. I'm a developer advocate at Vercel, and I'm so excited to talk to you about this topic because honestly, databases are difficult, and I want to show you how easy Prisma makes them. I'm going to break it down from scratch, explaining Next.js and Prisma, then go into some live coding to build out a full stack contacts application. So let's get right into it. In this talk, we'll briefly discuss Next.js and some of its main features, then introduce Prisma, and then finally, we'll be doing some live coding, which will be the majority of the talk. So why would you use Next.js? Well, Next.js, the SDK of the web, is the easiest and most popular way to build production-ready React applications. It's been growing at an incredible rate the past few years, and there are many, many companies from startups to enterprise level using and loving Next.js. So let's talk about some Next.js features and how they can help you become a more effective developer. First off, Next.js provides you with pre-rendering and several data fetching techniques, including server-side rendering and what you're typically familiar with, client-side rendering. This is so you can build any application you want, from a static landing page to a large production web application with many moving parts. You can choose what works best for your use case on a per-page level to optimize your app's performance and delight your users. Two other cool features that Next.js gives us are file-based routing and API routes. With file-based routing, you can simply create a file in the pages directory and it'll become a route, as I'll demonstrate shortly. With API routes, Next.js blurs the intersection of front-end and back-end by giving us the ability to write serverless functions right from within our Next.js repo. In terms of support and optimizations, Next.js comes with built-in support for your favorite developer tools, including TypeScript, CSS and JS libraries, and CSS utility frameworks like Tailwind. It also gives us an image component that does image optimization and lazy loading right out of the box. And finally, with automatic code splitting and bundling, Next.js only loads the JavaScript for the current page that you're on. And this is great because less JavaScript is shipped to the browser, making your application more performant. And with the newest release of Next.js 12, there is now support for middleware, which allows you to run code closer to your users at the edge and enables things like A/B testing and feature flags. There's also a brand new Rust compiler that gives us 3 to 5 times faster refresh and builds, and React 18 support for things like suspense and React server components. All in all, we get an extensible framework with great defaults that takes care of many things we would have to do manually out of the box, and ultimately allows developers to be as productive as possible. So as I mentioned before, I work for Vercel, which is a front-end cloud platform. We have this mantra called develop, preview, ship that I want to mention real quick. We enable developers to develop applications using whatever tools they're most comfortable with, then enable them to collaborate with others through tools like Next.js Live and preview URLs that you can share with your team and collaborate on until you're happy with the final result. And then finally, you can ship it by committing to your main branch and letting Vercel handle the rest. It'll immediately be available on Vercel's global edge network, and it takes care of a lot of the hard and boring parts for you, like setting up domains, DNS, SSL encryption, caching and validation, and so on. And we're also the creators of Next.js here at Vercel. So now that we've talked about Next.js and Vercel, let's talk about Prisma. So Prisma essentially makes databases easy and allows us to talk to and perform actions on our SQL databases directly from our JavaScript code. So before Prisma and tools like it, if you wanted to use a SQL database, you needed to learn and then write raw SQL. But with Prisma, you can use their API to interact with your database in 2 easy steps. First, you need to create your schema, and then you can use Prisma's API within your code. So let's take a look at how that works. Here is a sample schema. We first define the type of database on line 6, then we include the database URL on line 7 that we provision on Railway or Heroku. After this is set up, we define our database schema on line 10. Here, we're telling Prisma that we want a SQL database with the name user that contains an ID field, which is of type integer and auto increments, a first name and email fields, which are both strings, and finally an active field, which is of type Boolean. After we've defined our schema, we can simply use Prisma's API to query it from our newly created SQL table. After we've defined our schema, we can simply use Prisma's API to query our newly created SQL table. We use prisma.users.create to create a new row in our users table, passing in an object with the field name and values that we want to use. So in this case, we're passing in Alice as the first name, alice@prisma.io as the email, and true as the active field, and this will create a row in our table, just like that. So now that we've talked about Next.js and Prisma, let's dive right into the code. This is the demo that we're going to be building. It's called Contacts with a Z, and essentially you can add a contact using this form to the left. You can add a first name, a last name, an email address, and an avatar, and then when you press submit, it adds a contact to the right here with this specific card. So let's dive right into the code for this. I have a typical Next.js project structured here, and I'm going to be going over it. So we have a components folder, which is where all of your React components go, and then they get imported into a pages folder in Next.js. So this pages folder, it has the typical app.js, and then it has an index.js, which is actually the root, the home. So this is where all of the code in localhost 3000 is going to be, and then if we have any other routes, they would show up here. Because of the file-based routing system that Next.js gives us, to add a new route, instead of, in a typical React application, we would create a component. If we wanted to add an about page, for example, we would have to create an about.js component and then import it into app.js or whatever component is going to be rendered, and then use a bunch of switch statements from React Router. With Next.js, it's as simple as creating a new file called about.js, and then we can define a component here. So we're going to do export default function about, and we're simply going to return a div with this is the about page. And all we have to do is save. We go back over here, we go to /about, and there we go. Our about page is live, and it's really that easy. I'm gonna go ahead and delete this for now. You may notice we have an API folder in here as well, and this is where Next.js allows us to define and add serverless functions and use it within and outside of our application, as we'll see shortly. We also have a public folder where we drop all of our assets. For now, we just have our favicon. And then finally, we have a styles folder, which contains all of our CSS. Next.js ships with CSS modules by default, which, if you haven't heard of, is a way to locally scope CSS. So for example, we have a user.module.css folder, which is just a regular CSS folder, but specifically for the user component. So if we go to the user component, we'll see that we import the CSS modules folder in this specific way. We use import styles from whatever it is, and then we invoke these styles using styles.container, for example, and styles.name. And so if we go to the CSS file, these are just, these class names that we're using. So now that we've talked about the overall structure for our application, let's dive into the homepage code a little more. So I'm going to open up pages and then index.js, and we're going to talk a little bit about this. So I'm going to scroll down to the JSX for now. And so essentially we have a head component that Next.js gives us, and it's a way to define meta tags. We're using it for the contact's title as well. And then we have an H2 over here with our header. So let's actually go back to our main localhost 3000. We have our header up here, and then essentially we have a left and then a right if we go down here. Right, so we have two divs that kind of split up our page, and they're splitting up our page to the left and to the right. Right here we have our form, and here is where we're displaying our contacts. So we have a typical form here. We have a form, and then we have all of our inputs for first name, last name, email address, and avatar on the left-hand side. And then on the right-hand side, we are simply showing all of our users. So for right now, I hard-coded this data in. So it's just essentially me and then a few of my teammates from Vercel. And this is coming from the user component over here that we've defined in components. So if you go to it, it just takes those four things as props, and it displays them using the Next.js image for the avatar. Okay, so now that we've talked about our JSX down here, let's scroll back up and talk about what we're going to be doing during this live coding. So we have 4 to-dos in this page. The first thing we're going to do is connect Prisma and our Postgres database to this application, because right now all we have is a front end. The second thing we're going to do is create an API endpoint to create a new user. So this is our submit handler function that's going to be run when the user submits their form over here. Right, so as soon as the user submits their form, the submit handler is going to run, and what we want to do is we want to send a post request to an API endpoint that we're going to create for it to query our database and actually add, the user there. To do number 3 is simply going to query our database and get all of our users so that we can then display in our application, and that's to do number 4, just mapping over the data that we get and rendering it below as opposed to hard coding this. So let's get right into to-do number 1. To add Prisma to our application, the first thing we're going to do is open up the terminal, I'm going to open up a new terminal, and we're going to run npm install Prisma as a dev dependency. We're going to wait for this to run, and right after, now we're going to do npm install Prisma at Prisma/client. So this essentially helps us create an instance of Prisma to use in our application. So now that both of those are created, we're going to go ahead and run our first Prisma command, and that's going to be Prisma init. So as soon as we ran this, we saw that a Prisma file was generated, and then we have this .env folder as well. So I'm going to go ahead and minimize all these other folders, and we're going to explore these two things. Let me minimize our terminal, and we're going to go into this Prisma folder. So this Prisma folder has our schema. As we talked about before, it is saying that we're going to be using Postgres, and this is where we can change it if we were using another database. And then it has an environment variable here with our database URL, and that's going to be in this .env file right here. So what we're going to be doing is, let's actually go create our database in Railway. So I'm going to go to Google Chrome, I'm going to go to railway.app, and you can see I'm not logged in at all. We're going to click Start a New Project, and then we're going to click Provision Postgres. And Railway is essentially spinning up a Postgres database for us to use, and we'll see how easy it is to use that. And we're going to grab that URL and put it back into our .env file, because that's the database we're going to want to use. So it looks like Railway is done. Again, we can claim this project if we want to log in, but for now I'm just going to grab our database URL. I'm going to go to Postgres and then connect, and then we can grab this Postgres connection URL. I'm going to copy it, go back to our VS Code, paste it right here, and hit save. And that's about it. I've just connected our database URL to Prisma. We still have to run a command, but I'm going to hold off until we finish our schema to do that. Let's finish our schema by defining the model that we want our database to use. So this is going to be user, and we're essentially going to have these 4 fields right here, but we also need to add a unique field. So we're going to add that unique field. We're going to call it ID. We're going to tell Prisma that it's an integer and that we want to auto increment, and we're also saying that this is the ID, this is the unique field that we're using. After that, we can add in the rest. So we have our first name, which is of type string. I'm actually just going to copy paste this down. We have our last name, which is also of type string, our email, and our avatar. And the last thing we want to do here is we want to map this to our database and tell our database to create a table called users as opposed to user. So we do that with map name users, because that just makes more sense. And that's it. We've just defined our schema in Prisma, and we've just connected our database. If we go to our .env file, we just pasted that in from Railway, so that's live. Now we're going to go ahead and open up our terminal. We're going to clear it, and we're going to run npx prisma db push. And what this will do is this will push the changes to our actual Postgres database, and we'll be able to look at it in a second. Okay, so it says your database is now in sync with our schema. That's wonderful. We can run this command called npx prisma studio, so we can actually see our database. So you can see that we have a user model over here, and if I click on it, it shows us that there's no rows in this table, but it shows us all of the things that we defined in our schema, right? Our ID, our first name, our last name, our email, and our avatar. So that is wonderful. Now that we've connected Prisma in our Postgres database with Railway, we can get rid of to-do number 1 and move on to our second to-do. For this to-do, we're going to be creating an API endpoint to create a new user and then send it a post request in our submit handler. So essentially, when the user fills out our add a contact form and presses submit, we want to send a post request to an API endpoint or a serverless function that interacts with Prisma and adds the new user to our database. So we're going to start out right here by preventing the page from reloading. So prevent default, and then we're going to wrap everything in a try catch statement. So we're going to grab all of the first name, last name, avatar, and email, and assign it into an object called body. So go ahead and do that. And as soon as we've done this, now we can use the native fetch API to send a post request to our API endpoint, which we're going to create in a second. But for right now, we're going to be calling it create, so we can fetch API/create, and then we pass in an object telling it that this is first and foremost a post request. We're going to pass in a header that's going to tell it that this is of JSON type. So the content type is application/JSON, and then finally we're just going to pass in the body as stringified JSON. And there we go. And then we can finish this up with a catch statement that takes in an error and console.logs it if there is an error. And that's about it. We are, again, grabbing these 4 fields from the form, and we're sending it to this serverless function right here. Let's now create our API endpoint. We're going to go to our API folder, new file, and we're going to be calling it create.js. And the first thing we want to do here is import Prisma. We have this lib folder that we haven't talked about, but you're going to want to create a lib folder with the prisma.js. And I just grabbed this from the documentation. This essentially just spins up a new Prisma instance for us to use. So going back to our API endpoint or serverless function, we're going to import Prisma from this exact folder, so lib/Prisma, and then we're going to start our serverless function. So it's going to be export default async function called handle that takes a request and a response. And essentially we're going to be destructuring all of that information that we're getting from our index.js file. So our first name, last name, our avatar, and our email, we're going to be grabbing it from request.body, because that's what we sent in. And then we're going to create a new variable called result. And this is where we're going to be using Prisma's API. So we're going to do prisma.user, because that's the name of our table, .create. And this takes in an object inside data. And that's just going to be those things. So for first name, our last name, our avatar, and our email. And at the end here, we're just going to do response.json result to return back the result. So that is pretty much it. We can go back to our index.js. So to recap really quickly, we have this try catch statement here that grabs first name, last name, and avatar from our form, and we send it to this serverless function here called create that we just made. And what this does is it uses Prisma to add this to our database. So we're going to open up our terminal. We have our app running on this window, and over here we're going to type npx Prisma Studio to open up the database so we can visualize it. So right now there's nothing in here. We're going to go back to our contact app and we're going to add something. So I'm going to just add a user with my information. We're going to see how this works. So this is going to be the avatar, which, fun fact, you can go to github.com/whatever username you're at and do .png, and then you get an image. So we're going to press submit. We're going to go back to Prisma Studio and reload it. And we can see that our user is here now. We've just successfully interacted with our Postgres database from our front end. So we can go back to our code, and the other thing we want to do is add a little toast to our application so that when the user clicks submit, we get a notification saying that a user has been created. So we're going to be using the React Hot Toast library for this. So we're going to import toast and toaster from React Hot Toast. You're going to want to npm install this. I just did that. And then we can, at the end of our try statement, we can do toast.success and pass in whatever message we want here. So like contact added. And then we have to add this toaster component at the end. So we're going to do that here. And that should be it. If we go back to our form now and we populate it again with some dummy data, hello world, Hassan@world.com. And then I grab that same avatar. So over here, .png, and I press submit. you can see we get this contact added toast at the top. So that's exactly what we wanted. Now that we can add contacts to our application using our newly created API endpoint, we finished to do number 2 so that we can move on to number 3. So for this to do, we're going to be creating another API endpoint to grab all of our contacts to display them in our application. So we're going to be using a library called SWR, which is a fantastic library for data fetching. So we're going to do import use SWR from SWR. And then we're going to be using this down here. So we're going to have a fetcher function that essentially just uses the native fetch API and then returns the response as JSON. And then we're going to do const data error equals use SWR. And we're going to be querying our API called getAll. And we'll create this in a second. And we pass in our fetcher function in here. And we want to pass in one more parameter, which is our refresh interval. And we're going to make this 1 second. So let's go ahead and create this API endpoint. So we're going to go to our API folder that has our create.js, and we're going to create getAll.js. And in here, we're going to import Prisma again, like we did. So import Prisma from lib/Prisma. And then we're going to create our handle function. So export default async function handle. And again, this takes a request and a response. And this is actually going to be super quick. We're going to be creating our result variable again, and we're going to be using Prisma with await prisma.user.findMany. So that's the Prisma command to actually return everything in your database. And then we're just going to send this back as JSON. And that's it. So now we can go back to our application. We've used SWR to send a GET request to our getAll serverless function over here, and it should return everything and store it in data. And then if there's any errors, it'll do that as well. We're missing a comma over here. So let's actually just console log this data to visualize it. So data is data. So we're going to go back to our application. We're going to go to our console, and we're going to see that we get data, which is an array. And we can see that it passes in the information from our database, which is fantastic. You can see we have our ID, our first name, our last name, our avatar. So we have all of that information as an array of objects. So now that we have that, to-do number 3 is done already, and we can move on to our final to-do, which is to actually map over this data from our Postgres database and render it below. So we have this information stored in this data variable here from our SWR, and we can just map over it down here. So the first thing we want to do is delete the static data so that we can map over our actual data from Postgres. So I'm going to delete everything except 1. Or we can just comment it out for now. And then we're going to say, if data exists, we want to map through data, and we're going to destructure the first name, last name, avatar, email, and ID. And then we're going to be returning this. So we're going to be returning all of this, and it's going to have this same format, right? Of user, first name is equal to, going to be first name. So we're going to do that. First name is equal to first name. Last name is equal to last name. We can have this avatar over here and our email over here. And then we just have to add an ID prop so React doesn't yell at us. So ID equals ID. And that's pretty much it. From over here, we are mapping over our data. We're grabbing our first name, last name, avatar, email, and ID, and we're essentially returning this user over here. So I forgot a parentheses over here. We're going to save, and this should work. So now that we've mapped over our data, let's go back to our application and see if that was reflected. So going back, we see that we do show those 2 contacts that are in our database. I'm going to go over to Prisma Studio, and we see that these 2 rows, Hassan and hello, are both displayed here. So now let's add a contact and watch it persist over here to the right. So I'm going to add my coworker, Steven. So Steven Tay, Vercel.com, and then we'll add his avatar. We'll press submit. It says contact is added, and we can see him here in real time. And the great thing about this, this isn't in React state, right? So if we reload, we have the same information that's still there. And this is because this information is stored in our Postgres database. So I go back to our Prisma Studio and I'll reload, the database information is right here. We've just built our serverless application using Next.js API routes, Prisma, and a Postgres database hosted on Railway. But there's one issue. It's not going to scale very well due to connection pooling. This happens because each user request triggers a serverless function, which opens up a new connection to the database. In the case of our app, every time a user fills out the form to the left and creates a new contact, that opens up a new connection to our database. So if 100 users click create new contact, 100 serverless functions are invoked, and 100 temporary connections are made with our database. The problem is there's a connection limit on our database, and if that gets exhausted, requests will start to fail. Not only that, but functions opening up and closing connections adds latency and makes our app slower. This is where connection poolers come in, and lucky for us, Prisma has released their very own data proxy in early access. Let's take a look at how we can use this in our serverless application. To get started with Prisma Data Proxy, navigate to cloud.prisma.io and click New Project. Fill out your project name. We're going to type in the name of our project, which is Contacts. I'm going to be importing it because I have it in a GitHub repository called Prisma Data Proxy. I'm going to click Next, and then we're going to be using our own database. I'm going to paste in that database URL from the Railway Postgres database that we have, and then I'm going to click Create New Project. I'm going to wait for it to spin up, and then there it is, our data proxy URL. We have it right here. We can copy it, and then we can go to the Prisma documentation to follow how to set it up in our application. So let's open up our code editor with Chrome, and we're going to follow these steps for how to use this data proxy in our Prisma application. The first step is to generate a data proxy connection string, which we just did. Install the latest Prisma dependencies, which we've done already. Now we're going to be enabling the feature flag in the Prisma schema file. But before we do this, I'm going to navigate to our .env, and I'm going to replace our Railway URL with our new Prisma connection string. Just start with Prisma. And then I'm going to follow step number 3, which is essentially to enable this feature flag in our prisma.schema file. So I'm going to navigate to the Prisma folder, schema.prisma, and we're going to be adding that line right here. We're going to save. The next thing is making sure the data source URL is read from our .env, which we've just done over here. And step number 5 is to add one more environment variable to tell it the Prisma client that we're going to be using the data proxy, and then we're going to run npx prisma generate to actually generate our new Prisma client. So I'm going to open up our terminal. I'm going to type npx prisma generate, press enter, and it looks like it just updated our Prisma client, so now we're using the Prisma data proxy in our application. To recap, the Prisma data proxy sits in between our serverless functions and our database in order for us to avoid the connection pooling problem. So it helps us scale, and it also reduces latency in our application. The final step is deploying our application to Vercel. So navigate to vercel.com/new. We're going to import our Git repository for our contacts app. I called it Prisma data proxy. I'll press import. We don't want to create a team. And to configure our project, we're going to need to add some environment variables. One important thing about the Prisma data proxy is that it can't run migrations directly on it. So we're going to be running migrations on our Postgres database URL directly. So we're going to create an environment variable for that called migrate database _URL. We're going to paste in our Railway database address. And then we're going to have our database URL, which points to Prisma's data proxy. I'm going to go back to our code, our .env file, and grab this right here, paste it in. We're going to add it, and then we can deploy. The final thing we have to do before we deploy is actually go to our package.json over here, and we have to add these 3 lines. And that tells Prisma to run migrations on this migrate database URL instead of the main database URL. And it also tells Prisma that we're using our data proxy. So we're going to go ahead and press deploy and then wait to see what we get. And that's it. It looks like we successfully deployed our project to Vercel. Let's go to our dashboard and then click on our domain to see it live. And I added this sample user over here. I can add another one. Let's go to github.com/Stephen Tay. And then we'll add my coworker Stephen into here. And then we'll put his avatar.png. We're going to press submit. And we can see the contact has been added, and we can see it here in real time. So our application is working. So there we have it. We successfully deployed a scalable serverless application using Next.js in the Prisma data proxy. To find the code for this repo, go to github.com/nutlope/prisma-data-proxy. And I'm on Twitter at Nutlope in case you have any questions. My DMs are wide open. Thanks so much for coming to my talk, and have a great day.
Thank you, Hassan. It's great to see how Next.js and Prisma complement each other with a great developer experience. So if Next.js makes full-stack development fun and easy, Prisma does the same for your database. Moving on, I'm now excited to invite our next speaker, Jason Lengsdorf from Netlify, whose talk title is Deploy a Serverless Prisma and PlanetScale React TypeScript App to Netlify. Jason Lengsdorf, in case you're not familiar, is the VP of Product Experience at Netlify and the host of Learn with Jason, a live-streamed video show where he pairs with people from the community to learn something new in 90 minutes. He's passionate about building healthy, efficient teams and systems. And now, without any further delay, I bring you Jason.
What's up, everybody? My name is Jason Lengsdorf. I'm the VP of Developer Experience at Netlify and the host of Learn with Jason. I'm really excited to talk to you about what's possible with web applications today and without needing to become a truly full-stack developer. But I thought it would be more fun, instead of me just telling you, I'd love to show you. So what I'm going to be doing today is I'm going to build a Vite app using Vite.js. We're going to build it with Preact and TypeScript. I'm going to use PlanetScale as a database, and I'm going to connect that database to my TypeScript app using Prisma. And then we're going to deploy the whole thing to Netlify. So we're going to do that all in the span of about 20 minutes. So, buckle in. This is going to be a bit of a speed run, but I just want to show you how much power we have as developers today to build a whole lot without a whole lot of time. We're going to start out in the terminal. I'm going to make a new directory. We'll call it Prisma Serverless PlanetScale Netlify. And then I'm going to move into that folder, and we're going to npm init vite at latest to make sure we get the latest version. And I'm going to make sure it shows up in this folder, so add a dot. So here we go. Then we need to give it a name, so we'll call it Prisma Serverless. We don't really need this. I'm going to go into Preact, and then I want to use Preact TS so that we get the TypeScript. So now that I'm in here, I can run npm install, and that will install all of our dependencies. So Preact, Vite, all the things that we need to actually build this thing. And then if I run netlify dev, it will auto detect that we're using Vite and get my dev server up and running. So here we go, netlify dev with Vite. It's got everything running, including a proxy that we'll use for serverless functions later on. And here's our site. Okay, so that's all good. We want to do that. So the next thing we're going to do is we're going to sign up for our PlanetScale account. So I'm going to hit get started. Now I already have an account, so I'm going to hit sign in instead, and I'm going to use GitHub. Now, once we get in here, it is going to show you a screen like this. It shows you how PlanetScale works. Now, I'm going to skip this for time's sake, but I'm going to hit this no thanks, I've done this before down here. And I'm going to call this database Prisma Serverless. And I'm in Portland, Oregon, so I'm going to choose Oregon. And now we will create our database. So I've got a database here. Now the next thing that I want to do because I've got this set up, is I need to install the PlanetScale CLI. Now I have the PlanetScale CLI already, which you can see here. If I didn't, I would follow the instructions for installing the PlanetScale CLI, which are in the docs. I will link to that in the show notes, so make sure that you check that out if you're trying to get started. So what I'm going to do is make sure that I'm logged in, so pscale auth login, and this will open up the PlanetScale site. It gives me a device confirmation code. If I look down here, I can see what this device confirmation code is. So there we are. We know that it's true, so I can confirm. And now I am logged in. There we go. All right, so the first thing that I want to do is, because we are going to be developing on this database, I want to create some branches. So the way that this works is PlanetScale's CLI is really powerful, so I can just run pscale branch and create, and I want to create it on my Prisma Serverless database, and I'm going to create a branch called dev. So there we go, it's creating a branch, done. Next, I want to create a shadow database. So this branch is going to be used by Prisma for migrations. I don't really know how it works, but the nice thing is I don't need to know how it works, because again, these services handle all this stuff for you. So pscale branch create Prisma Serverless shadow to create my shadow branch. And now what I want to do is I want to connect to both of these locally, because in order to do any of the setup stuff that I need to do, I need to have root access, and you can only do that, as far as I know, locally. So I'm going to go pscale connect, and then we'll go to Prisma Serverless, our database name, and then I choose my branch. So I'm going to say dev, and I want to make sure that I've got multiple connections open, so I'm going to choose ports. So 3309 is going to be my first port. All right. And now it is connected. You can see that we're at 127.0.0.1, port 3309. All right, let's do another one. So the next one is going to be pscale connect, and it's going to be Prisma Serverless shadow. And for this one, let's use a port of 3310. Here we go. All right, so now that's connected. Okay, so now that we've got those connected, I am going to head into my code here. So let's go back to this first one. I'm going to code this. We'll open it up. And this is my source code for my site that we just created using Vite. So inside here, I'm going to create a new file. We're going to call it .env. And inside of here, I need to create a database URL and a shadow database URL. And these are going to be used by Prisma. Now the format for these is, we're going to quote it because there's some special characters here. MySQL root at 127.0.0.1, then the name of our database, so Prisma Serverless, and that is it, actually. So, oh wait, I forgot the port. We need to include the port. That's very important. So now that I've got this, there is my root at our local server at the port that we specified. And then for the shadow database, it's the exact same thing, except we're using a different port. So this gets us to the two different branches, right? Now that, once we've saved it, will allow us to actually connect to Prisma. So the next thing that we want to do here is initialize Prisma in our app. So I'm going to go back out here and I'm going to install it. So the first thing I want is the Prisma tools. This is going to give us access to the Prisma CLI. I'm going to install that as a development dependency because we don't need it in production. And then I also need Prisma client. And that's going to be what we use in our serverless functions to actually read and write to the database. Once these are both installed, I can run a command using the Prisma CLI. I'm using npx, so I don't have to install it globally, or an npx prisma init. And this will build a couple things that we need. So first and foremost, we get Prisma. Here it is, all right? And that gives us a schema.prisma. We're going to need that. And then if we didn't have it, it would show us that we need a database URL, right? So because we've got this already set up, it didn't do anything. That's a nice little feature of Prisma to not break our stuff. And then in here, we need to make a couple adjustments. So the first thing is it tells us who made the setup, the generators, Prisma client.js, and then the data source for our database, where things come from. And the first thing that we want to do is we're going to add some features. So in order to work with planet scale, we are going to use something called referential integrity. I'm going to be completely honest, I don't know what this is. I just know that we need it. So I am following instructions here. Next, we're going to switch from Postgres to MySQL because that is the planet scale way. Then we're going to switch out to include the shadow database URL, and we'll use that environment variable there. This is a little helper from Prisma to pick up your environment variable, so we can set that. And then the last thing is now that we have referential integrity, we're going to set it to Prisma. Again, not 100% sure what that is, but I do know that it's important. So now that we've got the connection set up, we need to tell our database what it needs to actually be. So we're going to set up a model. Now I'm using a post model. This is, if you've read some tutorials about planet scale, you might recognize this model because it's one that I borrowed from David Park. So what we're going to do is we're going to have an ID that is going to be a number that auto increments. We're going to have a created at, and that is going to give us date time, and it will default to right now, which is really nice. Here is an updated at, and that is also a date time. And this one, we have a shortcut to just say, hey, when was this updated? Put that in there. We can set our title to be a string, and this is going to be a varchar of a maximum 255 characters. And finally, content can be a string. Okay, so that's our whole database model. We're only going to allow for posts. This is not going to be the most complete example, but we will be able to read and write from the database, and we're going to be able to do it in 20 minutes, which is pretty dang exciting. Okay, so now that we've got this set up, we can actually configure Prisma using this, and that'll update our planet scale database as well. So I'm going to run npm or npx Prisma migrate, and then I'm going to use the dev command, and that will pick up this schema and modify the table structure in planet scale so that we can actually use it. So this is my name for it. I'm going to call it init, and that gets us set up. And you can see here now we've got a migrations folder, and it'll show us kind of what happened here. This is the SQL that runs under the hood. Again, we don't have to care about this at all. What I am going to do though is I'm going to go into my database here, and I'm going to check this box to automatically copy migration data. Now, as far as I know, this is kind of optional. Like, I don't know that you need it, but what it's going to give us the ability to do is track this migration data as it happens, so that if you need to go back, you can find all the metadata that was used. I'm not a database administrator. I'm just kind of following instructions here, and so far it all seems to work the way that I want it to. So now that we're out here, we've got our database, everything is working. And here's the really exciting part. Now we can actually start writing data, and we can do that using this built-in npx Prisma Studio. Now what the Prisma Studio does is it builds a little UI that runs localhost, and inside of it, you can just edit your stuff. So here's our post model that we created. If I click into here, I can add a record, and it'll say, look, it's going to auto increment this ID. It's going to show up when it was updated. Here's our updated at. So I can click in here and say, hey, a post. And then let's add some content. And my content is going to be, this is very informative. All right, and I click out of here, and then we can see here that we can save changes. I'm going to save. All right, so now we have a post. This post is now usable in our stuff, so we can connect and actually read it out. So why don't we do that? So to do that, I'm going to stop the studio because I don't need it right now. And I'm going to run npx Prisma generate. What generate does is it takes the schema and it creates a Prisma client that will have TypeScript definition so that we can autocomplete all the things we need to interact with our database. This is super, super, super handy. And you can see here that it's given us something to copy paste. I'm going to copy paste that. And then I'm going to come over here and create our first serverless function. The reason I'm using a serverless function is I want to very strictly control the way that anybody can touch this. So I'm going to use Netlify's auto detection here, Netlify functions, and we're going to call this one posts.ts because I want to use TypeScript. And I'm going to import this Prisma client. And then down here, I'm going to export async function handler, because that's what a serverless function needs to export, is a handler. And inside of it, I'm going to do a try catch block. And in my try catch block, we are going to, if anything goes wrong, just return that error. So we'll catch an error and we'll say return status code of 500. This is an HTTP status code. So it'll just say, hey, our server failed, something went wrong. And we'll just stringify the error because we don't know what it is, but this should give us at least enough of a clue to go kind of hunt it and figure out what happened. Now in here, what we want to do is we want to try to get all of our posts, and Prisma makes this really easy. So when I go here, I can go to post, look at that, it found our post type, and then I can just go find many. All right, and if I hover over this, it's got all this information, including a sample of get all posts. Okay, so that's just a function. I'm just going to call that, right? All right, there we go. Good. Done, done, done. We are very happy. So then I'm going to return a status code of 200, and I'm going to send a header. We'll say that it is a content type of application JSON, and then that's all we're going to need there. So then down here as a body, I'm going to JSON stringify the posts. All right, so that's going to be our serverless function that actually lets this thing run. So let's just give it a shot. Let's try it. So I'm going to run in Netlify dev. And this is going to start the server. It includes a proxy. You can see here that it loaded our environment variables from the .env file. And then if I come out here and I run .netlify functions posts, it gives me my post. Okay, so we're now reading from the database. This is great. This is exactly what we wanted. Okay, so step one done. The next thing that we want to do is we want to be able to actually write new posts. So let's create another one. I'm going to create a new file. We're going to call it post.ts. Inside of this, we're going to use that same Prisma setup here, and we could probably make this more efficient. I am building a demo, so I'm going to let the Prisma team tell me what we should be doing here to make sure that we're pooling connections and all the things that need to be done. And this one is going to take an event. We want to actually pull the title and content out of the body. So I'm going to get title and content, and we're going to get those from JSON parsing the event.body. All right, so this gives us the event.body, which is whatever we post to this function. So then again, we're going to try catch. And if it fails, I'm just going to use this same catch block. So let me copy paste that. And we're going to drop that in right here. So what we want to do is first, we're just going to await prisma.post.create, autocomplete that. And then here's my data. And so the data that I want to send in is going to be my title and content. Everything else gets auto-generated, so I don't have to create any of those. And then assuming this works, we're going to send back a status code of 200, and we will send back a body of post created. We don't actually need this. We just need to send back something so that we can verify that the thing worked. And now that we've got this, we'll see that Netlify dev has picked up that new function. And so I'm going to test it by going into Postman. So here I've got localhost 8888 set up. So let's go to Netlify functions and post, and I've got it set to use post. So then I'm going to go into my body, and I've already got a title and some content set. So if I run this, we'll see, here we go, we got a post created. And when I come back out and run this again, now we've got two posts. So this is pretty exciting, right? We've already got read write going. So let's see if we can, in just a couple of minutes, build out a front end for this. So I'm going to go into my app.tsx here. And inside app.tsx, I'm going to clean house. Let's get all this stuff out of here. Gone. And then inside, I'm going to first set up some of the bits that we need just for markup, right? So let's start here. We'll say, first we're going to have an H1, and this is going to say my posts. All right. Then underneath this, we're going to set up an unordered list, and we'll do something in here once we have the posts. Then down here, we're going to set up a form, and it's going to say create a post, and underneath it, we will set up a form. This form is going to need to handle submissions, but we're not going to do that just yet. We'll do that in a second. So let's set up an HTML4, and that is going to be for the title, and we're going to give it a title. And then down here, it's going to be a type of text. It's going to be an ID of title that needs to line up with the HTML4. It needs a name of title. That's what we're going to use in the serverless function. It's going to need a value. We haven't created this yet, but we're going to give it a value, a title. And then on change, we are going to feed it a function. And this function is an event. That event is going to be set as the title. We're going to use state here. So this is going to fight us because we haven't imported it yet. But what I'm going to do is do some casting of this as an HTML input element. Let's go input. There it is. Because otherwise Preact will yell at me. And then we get the value of our target, right? So that just means anytime somebody changes this function or changes this input form, use it as the value. So then we're going to duplicate this whole set. I'm going to change these all to say content. Oops. Content. This one needs to be capitalized. Okay, all good. This one also needs to be capitalized. All right. And then we need to go up here and actually use this stuff. So let's import use state from, and we're using Preact here. So we're going to go Preact hooks. All right. So then I can const title set title, and that's going to be use state and an empty string. I'm going to duplicate that, and we will make it content. Capitalize it. It's going to be content. All right, we're happy. So now if I go to save this, let's give it a button first. Then this button is going to be button type submit, and we'll say save. All right, now I'm going to make a couple quick changes to the CSS as well so that it looks less terrible. So let's go with HTML and body. I'm going to use the sys font here. I've got a shortcut to make that happen. And then I also need to just make our labels and buttons just a little bit less junky in their sign up. So I'm going to go display block and a margin top of 1 rem. Okay, that should be good. All right, so let's go look at our app. So I'm coming back out here. And now what we'll get is we can see we've got our post, we've got the ability to create a post, and when I type, our post updates. Okay, so that should be good for us to actually build things. So going into app.tsx here, then I can come up and we're going to add a couple more things. What I need first is I need the ability to load our posts. So what I'm going to do is I'm going to get a use effect. So we're going to import use effect as well. And once this page loads, I'm going to run a use effect. And that, for now, can run right when the page loads. Okay, so then when the page loads, we're going to have an async function. We'll call it load. That is going to get all of our posts, and it will be an await of a fetch call, which will go to our Netlify functions posts. And when it comes back, that's going to give us a response, and we need to turn that response into JSON. All these little helpful overlays here killing me. So now that we've got this res.json, that should give us all of our posts, and then we need to set those to something. So let's set posts. We'll have to create that, and we'll set it to all posts. All right, so now that we've got that, let's get our post set up here. And I'm just going to duplicate this, and we'll say posts. And instead of an empty string, we're going to send in an empty array now. All right, so once we've got our empty array, we're going to actually call this thing at the bottom of our use effect. So when the component first loads, it's going to fire off this function to load posts and then set those as a posts variable in state. So then down here, I can actually use these. But in order to do it, I need a type for my post. So let's write a type real quick. And this type is going to be a post, and it's going to equal an ID, which is a number. It's going to have a title, which is a string. It's going to have content, which is also a string. It's got created at, which is date, and updated at, which will be also a date. So once I save this, then I can come down here and we'll say post.map, And for each of these, we're going to get a post, which is a post. And then inside, we can do fun stuff. So we'll set up a key. That key is going to be post.id. Good. All right. So now that we've got that, inside of it, I can set up, we'll call it an H3, which has got the post title. And this is all auto-completing because of TypeScript. I'm going to set up a paragraph, which will be created, and we'll just do like a new date of post created at. And then we'll go to locale string, and that'll be good enough for now. And then finally, we're going to set the post content. All right. And if I come out here now and I look, here are our posts. Okay, so we've got posts. So then the last thing that I want to do is I want to be able to create new ones. And I'm going to do that by creating a function called async function handle submit. This is going to be a standard handle submit. I am hacking the heck out of this because there's some stuff that I didn't have time to look up on how to type these properly. So we're going to just do an any hack. Sorry, TypeScript fans. We're going to prevent default. All right. And then finally, what we're going to do is await fetch, and we're going to send this to our Netlify functions post. And this is going to be sent as a post. It's going to get a body of JSON stringify our title and content. That's what we needed there. All right. So then once we get down here, we're going to clear the title. We're going to clear the content. And then the other thing that I want to do is I want to cause our posts to reload so that they show up. So I'm going to make a little flag for this. I'm sure that like David Khorshid would be very upset with me for what I'm about to do, but you know, he's not here to show me a better way, so we're just going to do it this way. So I'm going to do load posts and set load posts, and we're going to start it out as a use state of true. Okay, so we'll go down into load here, and what we're going to do is make sure that if load post is false, we only want to load if load post is true, right? So if it's false, we're going to return and do nothing. And then we want to, down here, after we've done the load, so on the initial load, it's going to be true, which means we'll get past this, we'll run the post. But then that means that we need to set this to false so that it doesn't run again. And then we want to have the use effect check every time that load post changes. So this should run every time that load post changes. Now the reason for that is that down here in handle submit, we're going to set load post to true. And that is how we're going to get every time we submit, it will update that handle load post. So now you can see this handle submit's not being used yet. So we just got to put this in place. What we are going to do here is we're going to say on submit, and we're going to pass in handle submit. Okay, so let's give this a shot. We're going to head over to our app. If I reload the page, we can see we're still pulling from the database. And now I should be able to add a new one. So we'll say another one and created from the UI. Let's save it. And there it goes. It clears, it adds, and if I refresh the page, it's there. So now we've got a fully functional app. It allows us to load posts from the database. It allows us to create new posts. And I want to get this thing live. So what I'm going to do next is I'm going to go out. And remember, we've been running this on our dev branch and on our shadow branch. So to go live, what we need to do is we're going to take our serverless database, and we're on the main branch here. So what I want to do is I want to get into this main branch. I want to promote it to production. So I'm going to go into my branches here, and I'm going to click on main. I'm going to promote a branch to production. We're choosing main, and I'm promoting. So now that this dev branch is configured the way that we want it to be, I want to promote it to our main branch. And so this works really similarly to a pull request in GitHub. So we're going to do what's called a deploy request, and I'm going to create it, and I want it to go to Prisma Serverless, and we're going to set it for dev. So this will go to our production branch and create a deploy request #1. And then if I go out here, I can click here and we'll see here's a deploy request. So we can, and this is really powerful. So let's check this out really quickly. You can see the schema changes. So we can see the diff here. And then if I go back to this summary, I have an option to actually add to the deploy queue. So I can click this button, and this will start taking this live. So it's gonna, here it is deployable. They're being deployed. This takes a little bit of time, and once that's done, our site will be live. So while that's happening, there it goes, it's done. What I'm gonna do is I need to get my my connection string. So I go up to this connect tab. Now keep in mind I'm on the main branch here. So I'm in the connect tab. I could run this through here, but I'm gonna do it through generate new password. And then I can choose Prisma right from the bottom here. And this gives me a password. So I'm gonna copy this. And then what I actually need to do is put this into my deployed app. So I'm gonna create a place to keep this. And we can see here that it's got, it's got the username, it's got a long generated password, and then it goes to the name of the app and which region it's in and all that good stuff. And then at the end, we see this SSL accept strict, which means that it's gonna make sure that all of the connections are secured. I only need this MySQL part here. So I'm gonna grab this and I'm gonna hold on to it. And now we're gonna deploy this app. So I'm coming over here, I'm stopping my server, and let's do the get status here. So I'm gonna get init. All right, so here's my app. This is everything that I need. So I'm going to just add a few things. So like we don't wanna track the .m. So I'm gonna add that to the getignore. All right, what else do we got in here? Let's go .netlify to .getignore. And then I can get add again. Let's do that check one more time. Okay, the .netlify stuff is gone. Great, I'm happy. So let's git commit, and we will say ready to deploy. Okay, so now we're gonna GitHub repo create. I'm using the GitHub CLI here, and it's gonna create a repository for us. It's gonna be public. I want it to have the same name as my folder here. So there goes that repository. Then I'm gonna netlify init so that we can create a new site from this repo. And this is gonna let me create and configure a new site. I'm using the netlify CLI here. I'm gonna put it on my own team, and we will call this Prisma Serverless. We'll just leave it at that. Then I'm going to keep the default. So it is a Vite site, so we'll Vite build. It's gonna use the distdir, which is the default. Netlify functions is where we put our functions. So off it goes. Now the next thing that I want to do is I want to add this database URL. So I'm going to use the netlify env set command, set database URL, and paste in this MySQL string. And that is now going off. There it goes. That is set. So we've got all this code. So I'm going to git push upstream origin main. And that is going to actually deploy the site. So then if I go out to my site and I can netlify open here, and then that's going to open it up in this browser. There it is. And we can see our site actually building here. That first one was an empty repo is why that failed. We hadn't pushed anything yet. So now that we've actually pushed up our code, it's going to go. It's got that database URL, and everything should, fingers crossed, do what we expect it to do. So off it goes. You can see here the site builds. Like Vite is just ridiculously fast. Took about 1 second to build the site, 2 seconds to package up the functions. So the whole site is done in about 30 seconds. That is just wild. And then if we come out here, here's our app, Prisma Serverless. Okay, but note this: there's no posts here, and this is actually intentional. Our production database does not have the same data as our dev database. So if I now want to create a new one, production post, this is in production, and I save it. Here's our post, right? And this is really powerful because it means each branch can have different content in it. That is really, really, really powerful for us. There are ways that we can merge the content in if we need to. It's just not something we're going to cover today. And with that, that is a full production app build deployed to the internet, actually functional, using serverless functions so that we can power a full site with a custom database. I hope you're walking away from this inspired. I hope you're walking away from this jazzed up to go and build something. I can't wait to see what you build. Quick shout out to Prisma Serverless. Thank you so much for having me. I will see you all around the internet. Thanks so much.
Thank you, Jason, for the thorough talk. I really enjoyed seeing Prisma, Netlify, and PlanetScale in action, especially after the interview between Sugu and Taylor, who covered a lot of the theory and motivations behind PlanetScale. Next up, We have Adrian Howard from CockroachDB, and Adrian's talk title is Serverless, Code More. Adrian is a Hoosier, that is a native of Indiana, US, living in the big city. He enjoys mentoring at hackathons and live coding on Twitch. Adrian began his career helping bring technology to schools by setting up computer labs and training teachers and staff. And now, without any further delay, the stage is yours, Adrian.
Welcome to Serverless, Code More. This is Atticus. He's the bestest boy. He's my 8-month-old tricolor Pembroke Welsh Corgi. You're probably going to see him running around in the background while I do this talk. Hi, I'm Adrian. I'm Atticus's human. I'm also a developer advocate at Cockroach Labs. You can find me most places on the internet, Twitter, Instagram, Twitch, as It's Adrian. And if you're interested in seeing more pictures of this guy, you can check out my Instagram. It's basically all it is now. Okay, we're gonna let you down. All right. So the term serverless has been overused. Let's take a minute to make sure we're on the same page. Serverless doesn't mean serverless. There are actually a lot of servers. But what serverless allows you to do is to deploy your apps and services without worrying about the infrastructure. It should really be called infrastructureless. But it's more of an out of sight, out of mind than a not at all. As the demand for your application increases, the serverless framework takes on spinning up new instances to meet the rising demand. And as that demand recedes, the framework will spin down no longer needed instances. Serverless is just a computing model that takes into account the following properties: on-demand and instant compute, instances that are dormant won't use compute, the task of scaling, planning, and configuring the infrastructure are handled for you, and you only pay for the compute you use. This frees developers to focus on application logic rather than the infrastructure. This serverless execution model has been picking up speed over the past 5 or so years. The top 3 clouds, Amazon, Google, and Azure, all have offerings to handle the serverless compute, functions, and app development. There are companies today that completely run on serverless. When I started working with serverless 4 years ago, it was a hard sell, but we're at an inflection point where more and more companies are turning to it. Now that we're on the same page, what about serverless data? This is where it gets interesting. Data complicates serverless. Today, you're responsible for determining the size and scale of your database up front. For a serverless database, you'd want these decisions to be made for you depending on your usage. The data should also exist as close to the user as possible, on the edge if you will. So that way your Sydney user can have the same experience as your New York user. And lastly, you want to be sure that the state of your data is preserved when your usage scales down to 0. This is what the team at Cockroach Labs had envisioned when creating CockroachDB. In many ways, CockroachDB was architected to be a serverless database from day one. CockroachDB scales horizontally given its distributed architecture. By automatically spreading copies of data across different data centers, we can ensure it's always available and reliable. Since the data are replicated and spread across the world, it ensures that all users have the same experience. And finally, CockroachDB supports ACID transactions to ensure consistency of the highest level, and developers can use any Postgres wire-compatible tool to work with it. CockroachDB Serverless builds on top of the core capabilities of CockroachDB. While CockroachDB can scale horizontally, CockroachDB Serverless performs that scaling without any manual user intervention. CockroachDB Serverless automatically replicates your data 3 times across 3 different data centers so that the data is always highly available. Consumption-based pricing is a key part of serverless, and as a user, you only pay for the compute when the database is actively used. CockroachDB Serverless automatically spins down any compute resources that are not used and back up again when needed, all without any user intervention. Traditionally, cold starts were a problem for databases. CockroachDB Serverless can spin up dormant clusters in 500 milliseconds or less. And we're able to keep costs low with a multi-tenant solution, meaning there are several end-user clusters on a single CockroachDB environment. These 6 capabilities constitute our definition of a serverless database. This is our North Star as we continue to build, expand, and evolve CockroachDB Serverless. With that in mind, let's see what the end-user experience looks like for CockroachDB Serverless. As an end user, the only decision you have to make is the monthly spending limit. This can be 0 if you want to be on the free tier, or up to 10K a month. We take care of everything else, whether that's scaling based on your usage or ensuring data is replicated and highly available. We will never charge you more than your spend limit. That is our promise to you. If you want to kick the tires without any commitment, we offer a generous free tier. No credit card required. All clusters are free by default. The nice thing is that regardless of your spend limit, if your actual usage is within our free resource limit, you don't get charged. So for example, if you have a $25 spend limit, but you use less than 5 gigabytes of storage and 250 million request units, then you won't be charged for that month. Now, if you do hit the upper limit of our free tier, you have 2 options. You can add a spend limit as low as $1 a month, or you can continue using the database cluster, but your performance will be throttled. Because we want CockroachDB Serverless to be as easy to use as possible for any developer, we've partnered with the Prisma team to build the Prisma CockroachDB connector. Support for the Prisma client and introspection will be coming soon with Prisma Migrate support to follow. If you're like me and want to start using the Prisma client now, you can connect using the Postgres Prisma connector. Let's take a look at using Prisma and CockroachDB Serverless using the Prisma Postgres connector. Since CockroachDB is Postgres wire compatible and strives for PostgreSQL compatibility, developers can often take advantage of existing Postgres integrations with CockroachDB. This demo is interactive, so feel free to grab your phones and text your GitHub username to the following Twilio phone number. For my example, my GitHub is Adrian, so I'd text Adrian. Don't include the @ symbol. I'll give you a moment to send your text. You should receive a personalized response like the following. This application will accept a Twilio SMS, perform a GitHub user lookup using the API, and respond with a generated image. Let's take a look at the 2 Netlify functions that make up this application. And again, if you're still typing in the phone number, I'll give you a few seconds. The first function is responsible for accepting a post from Twilio, writing information about the request to CockroachDB, and returning the appropriate TWIML response. So we have Brittany here. I'm going to call her Brittany. She's got a ponytail. She sends the text of her GitHub username to Twilio. Twilio then posts it to my Netlify function. The first thing it's going to do is verify the signature. Now, this is a step that I recommend with any webhooks processing, so that way you're verifying that the request is coming from who you think it is. So we verify the signature. If it's not correct, we'll return a 422 and stop functioning. If it is correct, we'll use the Prisma client to write to our CockroachDB database, and then we'll return a TWIML response. So the TWIML response looks something like this, but the media URL in the TWIML response will actually call our second Netlify function. This function is responsible for querying the GitHub API and returning a generated image. So whenever we give the media part to the TWIML response, it will make a GET request to this URL. It will use the query string parameter of username to get GitHub user info from the GitHub API. And then it will use that to generate the image. The image is created by using the Playwright API, which takes a screenshot of the React component that is rendered with the GitHub user info. Let's take a look at how we use the Postgres connector with CockroachDB Serverless. First, we create our model specifying the PostgreSQL provider. We then need to provide a database URL. I chose to store mine in an environment variable. You'll want to format your URL like this. You can find all the values in the Connection Parameters tab of the Connection Info modal in your Cockroach Cloud console. You'll also want to make sure your database name includes your cluster name and tenant ID. For example, mine is Courteous Corgi 744. And then we'll fill out some information about our message model. So I'm collecting the ID, the GitHub username, the SMS location, which is being stored as a JSON string, the function that's used. For this case, it's a JavaScript function, and the date that the record was created on. One caveat until the CockroachDB Prisma connector is released and supports migration, you'll have to create and modify your database tables manually. It's not fun, kids. But here I've created a SQL script to create the messages table for our message model. I can execute this using the SQL shell in the CockroachDB client. Now we can run the Prisma generate command and use the Prisma client in our serverless function. Here is the function responsible for accepting the post from Twilio and writing the request information to CockroachDB serverless. For each request, we insert a new message containing the GitHub username and location of the sender phone number to the database. Capturing the location of the phone number instead of the phone number itself allows us to store some interesting data without running into personal private information issues. I promise I'm not harvesting your phone numbers. It should be noted that if you acquired your cell phone number in one area and then moved to another, the location is associated with the phone number, not your actual location. So for example, I live in Manhattan, but I got my phone number when I was living in Indianapolis. It starts with 317, so my location is always going to be recorded as Indianapolis, Indiana, instead of Manhattan, where I live. If you're interested in looking at the source for this application, you can find it in my GitHub repo. It includes the functions to generate the image and how to deploy the Prisma client using Netlify. Also, check out some of our other serverless resources. Thank you. And Atticus is asleep, but he says goodbye.
Thank you, Adrian. It looks like some serious engineering went into CockroachDB, and with the new serverless offering, I really look forward to the fruits of the collaboration on the CockroachDB connector for Prisma. And now we're coming towards the end of the Prisma Serverless Conference. I hope that today's talks gave you a glimpse into how Prisma and the broader ecosystem is making the vision of zero ops and infinite scale a reality across the stack all the way to the database. I'd like to thank our speakers for taking the time to participate in this event and share their knowledge and insights. And of course, I'd like to thank all of you who joined us today. To try out the Prisma Data Platform, you can head over to cloud.prisma.io, where you can get started with Prisma in a couple of minutes. You can also learn more about the Prisma Data Platform at prisma.io/data platform. And to stay up to date, you can find us on the following channels. You can follow us on Twitter. Our Twitter handle is @Prisma. You can join our community Slack at slack.prisma.io. And you can sign up for the newsletter at prisma.io. So on that note, I hope that you enjoy the rest of your day, and we hope to see you again soon.